Hi, everybody. We're going to get started in just a minute or two. We'll just let the stragglers sign in. So feel free, panelists, feel free to test out your mics, see if everything's working. Everybody hears everybody okay? Make sure your cameras are working, and hopefully we'll have some smooth connectivity in our information communication technology showcase. But you never know. Rhys, you want to humor me with the mic check? See it's okay on your end?
I can hear everyone. Hopefully everybody can hear me.
Perfect.
We could hear you loud and clear.
Awesome.
Darsh, how's it on your end? You hear okay?
I think so, yeah. I can hear everyone, and I'm guessing everyone can hear and see me as well.
Awesome, good. With that said, I think we're going to get started as the last stragglers get in. Welcome everybody to the absolute last showcase of 2021. We'll see you on the other side, but in the meantime, I believe this is our 12th or 13th. I think it's our 13th showcase of the year. We had a unique showcase already earlier this week, which was exclusive for two audiences. One was for Air Force end users and stakeholders looking to potentially sign an MOU with Air Force SBIR winners from the AF Ventures or AFWorks program. And this is our second event of the week, and it's been a great last year. We won't do any recap of the year. I just want to say thank you for any of our panelists that have been on previous events, and thank you also for our panelists that this is their first event. It's been quite the year and quite the progression. Talk a little bit in a few minutes about our progression internally without going into the numbers. So without further ado, welcome to the ICT Showcase. We're going to be having 3 sessions today: open topic, computing, and connectivity. A word on us: we are the Deep-Tech Showcase, and we, beyond being a event planner, we're also a business development firm that helps companies that are developing deep technology to have their quickest, most a clear path to market on the one hand, and on the other hand, we also help tech scouts from government, tech scouts from corporations and investors to scout new companies and new technologies. The barriers holding deep tech startups are many. The obvious is when you're developing something which is high in R&D, it can be an enduring process that is not for the faint of heart, and it costs a lot of money and it takes a lot of time for that product to mature into market. And therefore, there's a lot of partnerships and other types of engagement and a lot of capital and a lot of time and resources that go into making sure that this technology successfully makes it into the hands of many end users. Often, because it is deep technology, it spans multiple markets, and some of the markets aren't even aware that this technology exists. So the difficulty here with all this investment going into R&D, that there's not enough investment that goes into business development. And so we have a real need here for these tech companies to not just orient themselves better, but also to understand how their technology can make an impact on different markets. And that's where we help. We help companies with a go-to-market strategy, and that's through our strategies division, with content and design, for converting their story into one that is palpable and which is attractive and touches the eyes, hearts, and ears of the market. Guided introductions to tech scouts when they're interested, guided introductions to investors when they're interested, marketing assistance to help you find target ideal clients, and of course through pitch events like the one today. We curated an ecosystem that started in December of last year, and now it has largely grown as probably, I think we can confidently say, is the largest ecosystem of deep tech in the world. But who knows, who's going to check me on it, but I think it is. And it consists of 2 parties: startups on the one hand that are innovating, and on the other hand, stakeholders. And stakeholders we'll define shortly. Anchoring anchoring the ecosystem beyond the fact that we have, on the one side, those that are sourcing new technologies, and on the other side, those that are creating. We have a monthly event which is based on a different industry theme. Like today, it's on ICT, which is an opportunity for companies in that industry to come out and stakeholders interested in that industry to come out as well. Stakeholders that we define so that we don't allow anybody who doesn't fit these three titles or these three categories to come into the community. Public sector, that's tech scouts that are largely on the federal side, but also some state and city reps and county reps as well. Tech scouts from corporations and investors. Those are the three types of stakeholders. So between that and the companies, those are the four types of members that are in the deep tech ecosystem. The reason we need this ecosystem is because there's a lot of noise out there. And that noise creates a distortion and an inability for two sides to meet. Those that are looking for new technology are inundated because it is known to everybody that they have capital or they have the ability to sign off on a pilot contract or maybe even purchase a company or make an investment. And as a result, everybody wants to talk to them. On the other hand, the companies that should be talking to them can't always make as much noise. And that has a lot to do with maybe all that budget went to R&D and they don't have the attractive and the sleek slide deck that others do. And they're not making a lot of noise because their budget didn't necessarily go to marketing. So that's why we need this community in order to make sure that the left hand and the right hand can meet one another. A little bit about us. So we've, over the course of time, we've added a different level of service into what we do. One thing that is important to note for if you're a tech scout or if you're an investor is that we have a strategies division. So we help the companies that we work with in many cases to build their go-to-market strategy. And that includes all elements of it, including the standards of the SWOT, but also prioritizing your market and planning how you're going to enter it all the way down to the end user. And what we do is we help them go from end user all the way back to where their company's at, so that they build out their R&D with their end user and their beachhead market in mind. And for those companies that already have a product in market, to do the same thing as they breach on their secondary or their third markets. And that includes interviewing end users when relevant. And so many of you as stakeholders have actually been interviewed by us for the companies in the network just to get an idea of what an insider look is like that. And that's an invaluable asset for everybody involved. We offer a number of different additional services on top of strategies. Of course, the showcase, which you're familiar with, you're participating in an event led by the Deep-Tech Showcase. But we have different divisions in the company as well, such as Deep Tech Marketing and Showroom, which comprise together the triple. And we believe that that's the best pathway to market that we can help the companies in the cleanest and most successful way. Deep Tech Marketing, in a word, is taking who your ideal client is that you've identified through your strategy and create a voice behind your technology, but also to generate sales calls, which hopefully will lead to your best chance for a pilot contract or initial sales for your company. Showroom is something that is becoming increasingly important in this era of pandemic that we're living, which is there are plenty of conferences out there and you can't always make it to all of them. And not only that, if you do go to the conferences, it's very difficult to navigate. Well, that's not so with our team. Our showroom team is versed in this. And what they do is they help represent you at a conference in order to create, very simply, follow-on calls with relevant leads for pilot contracts and sales. This is our team. My name is Josh Baron. I probably should have introduced myself in the beginning. I'm the managing director. Today, joining us on the call will be Asher Rudensky, our director of operations. Yuval Herman, you've probably all received one or two emails from Yuval Herman, also director of events. Also, Leora Moore will be in the background helping out with support, as well Brian Markowitz. And every once in a while, if you go over time, Brian will let you know. This is our event planning for the full 2022 calendar. Kicking off next is going to be Industry 4.0, but you can see we have quite a number of events scheduled, one a month. Our next event is going to be on January 27th to give us a little space from the upcoming holidays. And we're going to be focusing on two major topics within Industry 4.0. Of course, there'll be the open topic as usual, but we'll be focusing on the smart factory as well as advanced manufacturing, or as we like to call it, the brain and the brawn. Quick introduction to our panelists for today. For the first session, it's going to be a little bit of a smaller panel, but any of the additional panelists that signed on early, feel free to chime in. Mark Bodner from Worldwide Tech Services, from St. Gobain, Adarsh Sokar, and from Allstate Strategic Ventures, Rhys Schroeder. Companies will be pitching. There will be 5 companies pitching: Fuel Gems, Unspun, Preto Battery, Bluespace AI, and Project Vesta. Session 2, computing session, is going to be joined by Tina Tasakawa from TDK Ventures, for Yusaku Group Hanko, from Saber Capital, Guy Zabarsky, from Lockheed Martin, Ryan Hatcher, from Cityside Ventures, Doron York, from Google, Kenny Vasig, from VU Venture Partners, Deidre Williams, and from Octave Ventures, John Lee, and Allstate Ventures, Rhys Schroeder.
Asher, just a minor correction. Guy from Sabra won't be. I'm replacing him on the first and second sessions.
Oh, so the ID Rabinovich is going to be replacing and representing the Sabra investment group. Thank you. Pitching companies, 4 companies: Arch Nimbus, Edge Impulse, Tarden Silicon Systems, and Coherent. And the panelists for the third session on connectivity: from Shield Capital, David Rothside, from Shimizu Corporation, Shudaro Kano, from PVP Seed Fund, Frank Levinson, from TDK Ventures, Tina Tasakawa, from Yusaku Group, Hanko, from Saber Capital, Adi Rabinovich, ignore the picture, and from Allstate Ventures, Rhys Schroeder. This last session will have 4 companies pitching: Zenesis, Orweaver Sourcing, Connexio Cloud, and Symbet Corporation. Okay, so I think without further ado, we can actually get started.
Just as a minor correction, I'll be joining the first session, not the third one.
All right, happy to have you on the first one, and you'll be joining the second one as well, correct, Eddie?
Yeah.
Awesome. Okay, so let's jump right into it. We don't want to hold anybody beyond the allotted time, at least not too long beyond the allotted time, and we want to get started right away. So first up, pitching. Who do we have? From Coastal Carbon Capture.
That's me.
Awesome. Nate, you ready to go?
Ready to go.
Floor is yours.
Awesome. Thank you, Josh, and thank you, Deep-Tech. My name is Nathan Walworth. I'm the VP of Science at Project Vesta, and today I'm going to tell you about coastal carbon capture, a scalable, efficient, permanent carbon removal solution. Next slide. So we know today the climate crisis is here. Next slide. And in order to abate runaway climate change, we need to remove up to 18 gigatons of CO2 a year. That's 18 billion tons. Next slide. So today I'm going to tell you about a gigaton scale carbon removal solution. Sorry, a little slow here. Next slide. And so basically what we're doing at Project Vesta is we're accelerating Earth's natural process of CO2 removal. And we're doing this by using this mineral olivine. It's a naturally occurring, globally abundant volcanic mineral, and it's been removing CO2 from Earth for billions of years, although very slowly. When olivine dissolves in water, it traps CO2 in the form of alkalinity for thousands of years. And we are accelerating and scaling this process. Next slide. So how are we doing this? It's actually pretty simple. You can go to the next slide. It's actually, in principle, bringing sand to the beach. Next slide. And so what this looks like is to source the mineral olivine and to grind it up into what we call carbon removing sand. Next slide. And what we do is we transport large volumes of this carbon removing sand to coastal zones, and there you spread it over large areas to increase the surface to volume ratio, which accelerates the dissolution rate. Next slide. As olivine is dissolving, it's capturing CO2 and locking it away basically permanently for thousands of years. Next slide. And so what's unique about Vesta is that we are applying olivine deployment through the coastal nourishment approach. So as we know, coastal cities and towns are dealing with coastal erosion and also sea level rise. And so every few years they have to nourish their coastlines. That means they have to bring sand from elsewhere and shore up their coastlines to protect their cities and towns. So they do this with normal upland sand. So our approach at Vesta is to supplement these coastal nourishment projects with carbon removing sand. And through doing that, we can sell carbon credits on the market after proving that it's removing carbon. And we can also potentially create a free or highly reduced cost to these coastal nourishment projects because they cost governments tens of millions of dollars a year, and they also are a very big carbon emitting process. And so our goal is to turn it into a carbon removing process for these governments. Next slide. So for every ton of olivine, we would sequester a ton of CO2. It's highly energy efficient because we're using free wave energy. It neutralizes ocean acidification. That's a co-benefit. The ocean is becoming more acidic. That means organisms like coral reefs can't make their shells. So this counters that. And it's also future-proof. When you put olivine in water, it will continue to sequester CO2 indefinitely. There's no additional energy inputs or technology. Next slide. So right now we're prepping for our first field pilots in the Caribbean. We're also in the permitting process with several sites in the US, the Bahamas, and India. Next slide. So we have a hybrid structure. We're 1/2 nonprofit, and that's through a coastal carbon capture impact fund where we can accept tax deductible donations. And then we have a for-profit side as well where we can accept equity investments and for-profit grants. Next slide. So to date, we've raised over 6 million in non-dilutive grant funding, 1.99 million pre-seed round. And we've been doing work in modeling studies and lab studies for the past 2 years, built an interdisciplinary team of 14 and who are international. We've won several climate programs and accelerators. We've signed letters of intent with 3 olivine sources, 2 dredging companies, and 14 carbon credit marketplaces, and we've pre-sold $250,000 in carbon credits. Next slide. So we know the carbon market is the next $1 trillion market, and net zero pledges are skyrocketing from cities and companies. Next slide. If you stack us against other coastal carbon or carbon capture technologies, we enjoy a lot of benefits, including energy efficiency, cost effectiveness, no land or freshwater use. And I'd be happy to go over that offline with you at a later time. Next slide. And so at present, we're seeking corporate and government grants for research and development. We're also seeking early carbon credit purchasers who want to support novel carbon technologies, and we will be raising at later rounds. Thank you.
Awesome. Thank you for that, Nate. Very cool innovation using basically the earth to heal the earth. Let's open up the floor for questions. And if we could actually maybe do quick maybe 15 to 30 seconds, each panelist could introduce themselves. Maybe Rhys, you can start off.
Sure. Hello, everyone. This is Rhys Schroeder. I am with Allstate Strategic Ventures. We are the strategic corporate venture capital arm of Allstate Insurance Company. I've been doing corporate VC work for a little over 20 years now, most of it with Motorola and Motorola Solutions, but also I was 3 years co-founding Tyson Ventures in the food space.
Cool.
Nice to be here.
Thanks, Rhys. Adarsh, can you introduce yourself?
Yeah, hi everyone. My name is Adarsh Salkar. I'm with Saint-Gobain, which is a French material science company. I'm with the ventures group of Saint-Gobain called Nova. We are strategic investors and invest in early stage deep tech startups, and we also do strategic partnerships. Yeah, thank you.
Awesome, thank you. Mark Bodner.
Hi, Mark Bodner, Worldwide Tech Services, responsible for business development, strategic partnerships, a kind of new effort at both VC investments and M&A. About 15 years experience with Israeli and other VC companies on the investment side, banking side, founder of 2 failed startups. So that's me.
Cool, thanks, Mark. We have some other investors on also as well. I just want to get to Adi, who also is joining this panel, but we also get the others as well. Go ahead, Adi.
Hi, so I'm Adi Rabinovich. Until recently, in Samsung's open innovation, working on various sourcing deep tech technologies for the mobile business. And I recently joined Sabra Capital as a venture partner. We in Sabra in Israel represent several entities, several funds. The most kind of famous one is Altair Capital, 650 million fund, investing mostly in software projects in the West, in Israel. That's about it.
Cool. Frank Levinson, you want to introduce yourself?
Sure. Frank Levinson with Phoenix Venture Partners. I started a company in the area of optical communications and fiber optic components some years ago that went public and did well. And then began doing VC things again after 20 years of growing that company.
Cool.
And we focus on material science and photonics.
Amazing. Ryan Hatcher.
Hi, Ryan Hatcher. I'm the corporate technology scout for Lockheed Martin.
Short and sweet. Doron York.
Can you hear me?
Yeah.
Doran York, I'm the CEO of Cityside Venture. We are a VC group located in Birmingham, Michigan. We are early stage investing in disruptive technologies, specifically in the AI, mobility, smart mobility, and aerospace.
Awesome. Han Ko.
Hello, Han Ko, USACO Group, President CEO. We're an international venture capitalist group, basically, and we have offices across the USA and also in Asia. We focus on basically ICT and AI and blockchain. So looking forward to meeting you all. Thank you.
Awesome. All right, now let's bring it back to the company that just pitched. We just heard from Nate Walworth from Project Vista. Questions from the panel for Project Vista?
Hi, this is Mark. I didn't understand sort of like what the defensible technology or what's proprietary, what you guys have that other people don't have or can't do. Can you talk about that for a second?
Yeah, definitely. So, the process of taking olivine to the sand and distributing it, or to the beach and distributing it. So to actually do that in a way that maximizes carbon removal, there are no methods and deployment methods that actually exist to do that. There are methods to take sand to the beach to shore up coastlines, but you have to spread it in a proprietary way to actually maximize the dissolution rate. The other big thing is that there's actually no measuring and reporting and verification system in order to convert that carbon that's being captured into carbon credits, and that's what we're developing right now with our team.
Is there any IP on that?
Yeah, so we've filed for 2 provisionary patents, and it's a system of technologies. So there's not really one sensor. There's several things that need to be developed.
Got it.
I have a different question.
Just a quick question. Does those patents cover the use of olivine for this purpose?
Yeah, for the purpose of carbon capture.
Yes.
Yeah.
Slightly different question. Just a quick one. Have you guys done any study to compare the carbon consumed or energy used to produce a unit of olivine compared to the amount of carbon it is supposed to capture? How does that compare from manufacturing?
Yeah, we've done life cycle analysis, and we've shown that we could capture up to 20 times more carbon than we emit. There's obviously a little room in there depending on the distance from our sources to the mines and to the field, but at scale, that's what we can achieve.
Just a quick question.
It sounds like you really need a very careful, accounting of all that, including the transport to the site, including the distributing at the site, and so on. I mean, it's really important to make sure those numbers are well tied off, I think.
Yeah, that's right.
I don't want to take up too much time. Just a quick question here, Nate. Could you tell just a little bit more about your hybrid model? You mentioned that for-profit, nonprofit, and I don't, you don't have much time here. If you just elaborate a little bit, I think that you have a great solution. Okay, that's why I'm interested in your business model. Thank you.
Great, thank you. Yeah, so there's obviously a good amount of research and development we need to do, and for example, a lot of corporates and different companies would like to issue tax deductible donations to things like this. And so one half of it is we set up a structure where we're working with an entity that houses a nonprofit fund for us for things like program related investments. And so they can actually issue us loans that we can pay back in multi-year timeframes as we commercialize. So that way we can be open to things like many types of tax deductible donations. And then the for-profit side, that's equity investment or for-profit grants that we can take directly into a public benefit corporation is basically what we've set up. So I'm happy to go into it more offline with you.
Okay, yeah, well, let's get that. Yeah, let's get connected later offline here. And then just a quick question. So is your entity is a Delaware corporation, or what kind of entity is that?
Yeah, it's Delaware.
Okay, all right, thank you. That's good. Thank you.
Thank you.
One other question, can this be also used as a feedstock in any of the construction materials? Have you guys looked into that, or is that something that
so there is potential for that. And so as you can imagine, there's actually several types of applications all of them can fit into. We're focused on this dissolution at scale for carbon removal, but we do have some other R&D projects that are theoretically looking into that right now.
Yeah, I think it'll be good to connect offline on those ones.
Yeah, that'd be great. Thank you.
Awesome. Thank you so much, Nate from Project Vesta. Up next is Fei Yi from Bluespace AI.
Great, thanks, Josh. Hi, everyone. My name is Fei, and I lead business development for Bluespace. We are a Silicon Valley-based startup that provides predictive perception for all autonomy. If you could go to the next slide. Companies have been working on autonomy for over 10 years now, which begs the question, why isn't autonomy everywhere? This is because the deep learning approach that is utilized by most AV companies today requires millions and billions of miles of training data and HD maps for a vehicle to perceive the world around it and how it's changing. This approach leaves room for endless edge cases in the real world where an AV might not know how to handle the situation and unfortunately has resulted in accidents and fatalities, as we've all seen in the press. Performance perspective-wise, high latency and high compute often are required of these systems and make it difficult to deploy in public roads. Lastly, this approach doesn't scale. In order to enter new markets, you have to drive around for weeks, if not months, collecting training data and map the entire location before you're able to deploy. On the next slide, at Bluespace, we've developed a predictive perception software that measures the true motion of all objects in real time instead of relying on inference. Our software works with no training data and no HD mapping, meaning that it's scalable across geographies and can work anywhere immediately. You can use our software as a standalone perception module or as an add-on to any existing AV stack as an extra layer of safety and redundancy. Not only have we achieved what wasn't possible before in handling all objects in all locations, but we also provide additional benefits to the AV stack. First, with improved reliability. Because our software is motion first and we don't train on or classify any objects, we work in all situations. We also enable a faster reaction time for motion planning and controls. Most other AV systems require multiple frames of data in order to make a prediction about an object's motion. Bluespace is able to provide the full motion measurement in a single frame, allowing you to react immediately. We also run on reduced compute and can run on any automotive grade processor in the market. Other AV systems you might have seen require special AI chip or GPU, which can take up a lot of power and also significantly limit the range in batteries and EVs. Bluespace enables the commercialization of all autonomy. You can go to the next slide. As I mentioned before, our software works with no HD mapping and no prior training, two of which are the most capital and time intensive activities to deploy an AV. Because we don't collect tons of data and we don't operate on camera vision, our software is also free from data privacy concerns. And because our algorithms are measurement-based, we're certifiable by third parties like any other automotive system, and we avoid the common pitfalls and challenges with verifying and validating the black box approach of deep learning. You can move to the next slide. Our software works on all vehicle form factors and across all scenarios, on and off the road, whether it's four-door passenger vehicles, mining trucks, or military applications. Bluespace provides a truly scalable solution for ADAS and autonomous driving development. Next slide. We know how hard it is to build and test a perception system from scratch. So we've made it easy to engage with us in proofs of concept through our early access platform, where we provide a pre-calibrated hardware and software unit for partners to test with immediately. We've already completed a handful of POCs with automotive tier 1 suppliers and OEMs and have more underway. Next slide. Today, we're looking for additional partners to engage with through POCs, government contracting opportunities, and we're also raising our next round early next year and happy to meet with investors that might be interested in participating in our Series A. Next slide. If you're interested in discussing further, please contact us. Our team is comprised of AV industry veterans that have really pushed deep learning and AV development to its limits, learned from it, and built Bluespace. We've also participated in various industry accelerators and pitch competitions like the NASA iTech competition, where we were named a Cycle 1 winner, and also recently completed the SAP.io accelerator for new mobility. And in conclusion, we're Bluespace, 4D predictive perception for all autonomy. Looking forward to building the future with you.
Awesome. Thank you so much, Faye. Opening up the floor for questions.
I have a question. So I'm trying to I'm familiar with the GM's work in Israel on measuring speed using radar. So how do you compete here with all the kind of major corporations, all the players that kind of have their own in-house solutions? For that, what's kind of your competitive edge here?
Yep. So our competitive edge is our approach to perception. So there are many other players in the industry that already have perception software, but their approach is usually built on deep learning and training a system with millions of miles of data. We have a measurement-based approach where we're able to provide the full motion of all objects instead of inferring what that motion might be.
So you take it from what's your kind of input, a regular RGB camera or something
So
else?
our inputs are 4D sensors, so usually imaging radars or FMCW LiDARs.
So you already have Doppler data?
That's right, we do.
Okay. Sorry, to me it's not really clear, like how it would compete with the GM's internal solution. Never mind.
Yeah, so hardware alone, with 4D sensors, you already get Doppler, but that only gives you radial measurement, and Bluespace's software takes those inputs and makes calculations to provide full motion measurements. So radial, lateral, and yaw rate. And so we're able to provide additional measurements of the object and how it's moving.
Okay. Do you have anything on RGB, using RGB cameras, using vision alone?
We don't use camera vision.
Okay.
Any other questions for Faye? There's one question in the chat was, how do you protect your cybersecurity?
Yeah, so our system, we don't collect and maintain a lot of data. And so we're able to have a safe and secure system. And we're also able to be certified to be automotive grade. And so those concerns would be addressed through that validation process, like any other system in a vehicle.
Awesome. Cool. Time for one last question if we have it.
Do you have any current US automotive companies that testing your product?
Yep. So we're working with a handful of automotive tier 1 suppliers here in the US and abroad. Most of those partnerships are under NDA, but we are actively testing with them.
Okay.
All right. Thank you very much. That was Faye E. from Bluespace AI.
Thank you.
Up next is Prieto Battery, and pitching will be Mike Rosenberg, CEO.
Good, thank you. First slide, please. Next slide. I'm Mike Rosenberg. I'm the CEO of Prieto Battery. Prieto is an advanced lithium-ion battery company. We're developing a advanced 3D rechargeable battery that addresses all the shortcomings of traditional lithium-ion batteries. Next slide. Lithium-ion batteries today are pretty good, but there's still significant issues, particularly in the electric vehicle space. If we want to move to a complete transformation of the auto industry to electric, we need batteries that provide better range, can fast charge, that are safer, that can operate at minus 30 degrees, start up and work. And they need to be lower cost so you can have batteries in long range in vehicles that are lower priced. Next slide, please. Typical batteries are 2D type structures. They're layered like pancakes. And you typically have to make a choice in whether you're going to have long range, high energy density, so you make your anode and cathode very thick, or you have to make a battery that's fast charging, so you make your anode and cathode very thin, so the lithium ion doesn't have to transfer very far. We've taken a different approach. We've decided to do a 3D interdigitated battery that allows you to have both high energy density and fast charging in the same battery. Next slide. Now, 3D batteries have been around for a long time. People have made them in the lab, but never been able to manufacture them. So when Amy Prieto started this company, she said, okay, if I'm going to do this battery, I need to be able to manufacture it. So she started with manufacturing in mind at the beginning. And what she did is she looked at manufacturing processes and took out anything that was going to be high cost. So she wasn't going to use any clean rooms or dry rooms, nothing that required, 2000 degrees centigrade temperatures, nothing that required hazardous solvents or exotic chemicals or high priced chemicals. So what she came back to was deciding on using electroplating as her main manufacturing process. And then with that in mind, she then went and said, okay, what does my battery need to be made of to be able to make this work? And that's how she decided on the different materials that we're using within our battery. Next slide. The easiest way to understand our batteries, so let's take a look at this picture. We start with a copper foam, which has an enormous amount of surface area per given footprint. That allows you to get a lot of anode and cathode into the battery, but we coat the little metal tentacles of the copper foam with our anode. So the copper foam acts as the tool for the electroplating of our anode on top of that. And then we put an electropolymer on top of the anode, and then we coat all that with a cathode. So what you have is a lot of energy density within this footprint, but the layers are very, very thin. So the lithium ion doesn't have to go very far, so you get fast charging out of the same battery. Next slide. We've got working prototypes now. The image in the left-hand corner is our 3D battery compared to a 2D battery. Shows that it's much higher energy density, up to 5 times higher power density, 2 to 3 times more energy density. We've operated these things down to minus 30 degrees centigrade with starting up from a frozen start. We've gotten up to 300 cycles and they're safe. You can cut these things in half. They do not start on fire. There is no thermal runaway. So it addresses the key lithium ion safety issue that you have today. Next slide. As I mentioned, this is electroplating. Electroplating is used extensively in the semiconductor industry. It's water-based, it's atmospheric temperature, atmospheric pressure, room temperature, atmospheric pressure. And once you get the battery made in a reel-to-reel process, The rest of the battery manufacturing process is the same today. Slitting, calendaring, welding, stacking, same thing. Next slide. We have 28 patents issued over 7 distinct patent families covering materials, architecture, and the manufacturing process. Next slide. And we're looking to grow into or develop our process. So right now we're scaling the footprint of our battery, and we'll have that being tested in the transportation industry, auto companies, consumer industrial partners. We have 2 strategic partnerships, one with Stanley Black & Decker for power tools and one with Hercules Electric Vehicles for EV equipment. We'll be doing these pilot runs and testing in 2022, building a pilot plant in 22, 23, and commercializing in 25, 26. Next slide. There is competitors in this landscape. There's a number of different solid state companies that are doing things differently. I'd say the one big thing for us is we started with manufacturing in mind. So we have a low cost, high volume process already identified that we just have to modify to our process, where most other people are inventing their manufacturing process today. And there is no guarantee that they'll be able to do so. So we think we have an advantage going forward. Last slide. I'm a 25-year plus clean tech executive. Amy Prieto is well known in the battery industry. She's won the Presidential Early Career Award for Scientists in Engineering. She's got a number of different awards, and we believe we're on path to have a large working prototype next year and pilot plant by the end of 2023. With that, I'll open it up for questions. Thank you.
Can I ask a quick question, though? First go, if it's okay with you. Actually, I know the 3D battery has it's an innovation, and you made it actually manufacturable. That's a great idea. It's great. So I think it can be a game changer. My question is that just 2 quick questions here. So first, what is the lifetime of the battery? No, based on the 3D side of it. That's first.
Yeah.
question.
So the 3D, we've tested it up to 300 cycles so far, and that's 100% depth of discharge. If we do to what normal commercial charging is, like 80% of depth of discharge, then we are out to thousands of cycles. So we're continuing to improve that as we scale the battery, and we're targeting, for automotive applications, at least 1,000 cycles, which gives you, 300,000 miles.
Okay. And I know you secured 28 patents, which is great, and a lot of great intellectual property protection there.
Yep.
Are you at a liberty to work with the investors or companies overseas, or you have some restrictions on your funding, or nope? Okay.
No, there's no restrictions. We're able to work with partners overseas. Absolutely.
Overseas. Okay. All right. Thank you. Okay. Preston, maybe you can connect later. Thank you.
Okay. Sounds great.
I would think about adding one more characteristic to what you've got, which is a strategy for recycling.
Yeah, our batteries are recyclable. We have not designed the battery for recycling per se, but we know that the materials that we use are easily recyclable. The copper antimony anode, that's all something that can be separated. Our separator is a traditional polymer that again can be separated out and used. I think the only challenge we have is what all lithium-ion batteries have, which is in the cathode, where you have the nickel, metal, cobalt materials that have to have a process to do so. So I think when the recycling business develops, our battery will be easily recyclable.
I have a quick question. So were you in touch with the kind of the big lithium-ion batteries player, LG Chem, Samsung SDI, or not yet?
We have had some preliminary conversations. The company's been around since 2009. We've raised $20 million to date. And I know we've had some conversations in our past. But the prototype fully 3D interdigitated battery was really available in 2020. So it was a development of last year. We've had the anode previously, but the full digital 3D battery was developed 2020. So we've got a very small battery to date, but we've already scaled it by 60x over the last 2 months. So we're pretty excited about moving forward, and we're certainly looking to have conversations with the battery manufacturers, auto companies, consumer product companies, others, as we move forward.
Do you have your own manufacturing facility?
We do not yet. Everything is lab scale to date, but because we've determined, been working with the manufacturing in mind already, we're designing that first pilot facility as we speak. So we expect to have our first design by April, May.
Okay, and in terms of the manufacturing cost, do you have kind of an estimate whether it's on par with the mass scale lithium ion manufacturing?
It's not going to be any more than that for sure. It's electroplating. It's done at room temperature, atmospheric pressure. There's no hazardous solvents. There's no dry rooms, clean rooms. We're not handling lithium, lithium metal or anything of that nature. So the process should be simpler and lower cost, but we're doing the design now to verify that.
Okay, interesting.
Awesome. Thank you very much, Mike.
My pleasure.
From Prieto Battery. Up next is Unspun, and pitching will be Kevin Martin, CTO and co-founder.
Can you hear me?
Mike,
Okay?
just check there are a couple of questions in the chat you might want to answer. Yeah, Kevin, we hear you all good.
Right on. Cool. Awesome. Great to meet y'all. I'm Kevin. I'm one of the founders at Unspun. You could jump to the next slide. See, just this play. Here we go. Cool. So quick concept demo. We're very focused on textile manufacturing, and even specifically the 3D scan to fit side. So we'll talk more about this in a second, but our core tech revolves around both an additive manufacturing process, as well as this like mass customization angle from the 3D scan component. Cool, you can jump to the next slide. Quick bullet points, here's your notes if you need to write anything down. Our main point is textile manufacturing doesn't exist in the US. It will soon. We think the secret's fully vertical, automated, and additive. We'll talk more about what those mean. Fundamentally, the next closest thing to us, we're 5 times faster and about 10 times cheaper. And we can show why that makes sense. Then finally, just on the commercialization side and partnerships, we've taken a very focused approach in commercializing as we develop. So we didn't just build a tech and are trying to see if it works, but we actually have a consumer facing side of the company as well. So next slide, please. So kind of fundamental problem on this. Our big point is textile manufacturing will come back to the US. It fundamentally requires automation though. If it were to come back to the US via human labor, probably would have happened in the last few hundred years. Lots of tailwinds on this. There's geopolitical, there's automation, there's nearshoring, there's ports backed up. So fundamentally, we're trying to think about when one of the biggest industries in the world, a $1.5–2 trillion industry, returns to the US, what does that look like? So you can jump to the next one. At Unspun, maybe there's an next one. Yeah, Unspun, our mission is very climate focused, but also particularly looking at the overlap of profitability and sustainability. So we're thinking about where can we be creating gigaton scale carbon emissions reductions while also creating fundamentally just a more profitable manufacturing method, specifically focused on textiles. So in the next slide here, I can show you a little bit on, okay, what is the automation stack of textiles right now? Where do things work? Where do things break down? Fundamentally, you have this great discontinuity at the human sitting at a sewing machine. Very easy for very basic, low-skilled labor to do. Very difficult from an automation robotics perspective. Car chassis is easy to swing around and model and know where everything is. Soft fabric rolling over itself on the sewing table is surprisingly difficult. So there's a few different groups kind of really honing in on this like cut to sew step. This is where the automation chain has fundamentally broken. A lot of these others have great automation tech in there. But this is kind of the big blocker. And if you jump to the next one, we can show our solution. We actually were really quiet about this component until just 3 to 4 weeks ago, which we announced in Time Magazine. Vega is our new manufacturing process. It's seamless. We can use conductive materials and fundamentally it's additive. So there's a lot of different things we can do by building in 3D rather than just flat fabric. So wrapped around that, we've been thinking about that first commercialization spot. Our Tesla Roadster is bespoke, really leaning in on the on-demand component that's necessary in custom fit and working backwards from there. So if you jump to the next slide, I can't show you full video of our machine, though I can if you want to chat more later and we get some paperwork in place. Ooh, if you could mute this one, it might be really loud. This is a good catch. This is a 3D knitting machine, kind of next best process in additive or automated apparel manufacturing. Really great in that you can do effectively like near net final shape garments. Downside is that it's slow and it's expensive, about 2 hours to do a garment, and the machine's about $1 million. It only does knits. Knits and wovens are kind of two main categories. Not totally worth going through here. Our fundamental tech is wovens only. Big difference is we get that throughput from 2 hours to 9 minutes. That's at today's scale. That's not a theoretical. And CapEx is our machines are about $60,000. So if you jump to the next one, fundamentally, I think I even saw something pop up in the chat. Why does additive make sense? Fundamentally, there needs to be an additive step anyways of turning yarns into fabric. We're saying rather than just do that in flat fabric, you should just do that in 3D. So skip the need to go flat fabric, do the cookie cutter, cut and sew step to get to 3D, but just go directly from yarn to a 3D final product. Here in the next slide, just click on the consumer facing side. So we developed this core tech for automated additive 3D weaving. We've actually built a consumer facing brand around this concept as well. If you look at unspun.io, which is our website, you'll see that we're actually a custom denim brand. We do this all based on depth data captured from iPhones. We can make a 3D model of a customer and then perfectly build the garment around them. So they're on the far right, you're looking at top are real photos, bottom is our automated rendering side. We are focused on the consumer side on custom denim. So we convinced the head of design at Levi's to leave and join us because he was really inspired by this process. Here on the next slide, we're kind of showing some of our first 3D woven outputs. So this is all built in this. This is all built on this additive seamless process. These are garments that came directly out of the machine. And then quick warping through these last few slides. Fundamentally, we're thinking about, there we go. We're thinking about, this core technology needs to win on that raw automation scale. So speed, reliability, cost is going to be the big ones. We believe that this tech, we can make products cheaper in the US on demand than you can make ahead of time in Bangladesh, Sri Lanka, what have you. We're on our way there, not there today, but we think we're fairly close. Next slide, we can probably skip through a bit. There's a strong data component from the 3D scan. We're starting in the consumer side with fashion. We think it's strategic and like proving that this process can work. If you can make $200 garments, you can very easily make $1 million 3D carbon fiber parts and whatnot. Next slide on the additive angle, it's already happening. Shimaseki in this 3D knit world is big in Japan. They're already building these additive microfactories, and then if we kind of just jump maybe two more, I don't know, quick kind of overview on why does 3D weaving make sense. Maybe back one. It's seamless. There's a lot of different things that you can do. So by building a garment, knowing where you are, we can do things like make the knees thicker or put conductive heating elements all the way through the garment for our military customers. Or even a big one that we're seeing lately is like seam tolerant stack up. So lots of different reasons why we think going straight from yarn to that 3D makes sense. And then finally, just on this last slide, we are a venture-backed company. Maybe one more. We are a venture-backed company. Oh, sorry, maybe one back. I didn't realize there's one in between. We're a venture-backed company. Also have done quite a bit through SBIR already. We've done a fairly strong lap through the NSF side of things, are currently working with AFOA, DevCom, and are also in the process of seeking out other federal partners as we go through this process. Some other applications beyond just the proving core tech on the consumer side with custom denim, other things we've been exploring is the ballistics protection, a lot of the optical or conductive elements. We talked about reducing bulk and lots of those like localized performance optimization. So be that for pressurization or anything along those lines. And then we're based in downtown San Francisco, 3 founders plus an incredible team of engineers. My background is in robotics, surgical, a little bit of aerospace. My co-founders, Beth and Walden, both come from the apparel side, one on the technical design and another in being on the supply chain industry forecasting range of things. So yeah, I saw a few questions pop up in the chat. We could start with a live one and then I'll try and get caught up on that.
Now let's start with the panel for a second. That's a fantastic technology from Unspun. Questions from the panelists.
Maybe just basic question of kind of price in terms of price comparison, competitiveness of price to this kind of standard industry.
Yeah, so within kind of, I guess, two key comparisons. One, within the existing additive manufacturing approach, we kind of talked about that benchmark of about 5 times faster and 10 times cheaper. Within general apparel, we are working towards hitting cost competitiveness. So the bar for us and what we're working towards is this should be net cheaper than producing via human labor in choose your third world country. We haven't hit that price point switchover yet, but all indications are that we're well on track to do that.
Well, when do you estimate you'll do that?
With about 20 machines, because the throughput on this process is so high. And again, this is for benchmarking just at like bottom of the barrel apparel. So if we go to $1 million, carbon fiber parts, that's a very different game. But even just like type of apparel you would get at like Walmart, for example. With 20 machines in a single facility, we can do almost 1% of US denim. So we're really optimized for high throughput. So we believe that basically by the time that we get to our second factory installation, which is one more funding round from now with 20 machines, we can be proving cost competitiveness, producing products onshore at the $40 to $50 price point, which when you factor in everything else in the scale within apparel puts us at a cost competitive manufacturing process.
Go ahead.
Maybe I just make a recommendation for the panelists to push the raise your hand button, and then we'll be able to queue up. But Mark, go ahead.
Yeah, so maybe I missed it, just a clarification. You're focusing on large scale manufacturing, or you're focusing on the custom market? I know you mentioned both, but what's kind of your initial focus? You want to manufacture for big brands, or you want to manufacture for like bespoke, custom online suit companies?
Yeah, great question. We think about the technology progression here as a matter of getting to scale, very much following the Tesla approach. So our first product is an expensive Roadster. You don't sell a lot of those. You keep using that to work more towards that Model 3. So for us, the Roadster is the bespoke product. It's more on the luxury side. We can do small batches of, multi-$1,000 products, but ultimately we're working towards mass manufacturing.
A question on your IP position, and also for your 3D knitting, is it agnostic to the type of yarn, and how is the kind of fiber density compared to conventional, textile manufacturing?
Yep. We have 2 patents granted. We have 3 more filed. We spent quite a bit of time working with one of the leading patent strategy firms to map out the white space of this world and make sure that we're patenting the important choke points. We've done quite a bit in hardware. We've done some on the software process, and we've actually done some on the actual seamless 3D woven outputs. So fairly aggressive IP approach in that sense. And then the other question was on material compatibility. For the 3D weaving process, we're material agnostic. So there's a general range of elongation and ultimate strength that we need to tune to. So kind of just more of a question of modifying machines to fit. But so far we haven't found a material that we cannot use.
And how is the fiber density and performance of it compared to conventional textiles?
It's still fundamentally weaving. So there isn't, the difference is that we're doing it seamless and in 3D. So in the exact same way that you could get performance of a conventional woven garment, be that or either garment or carbon fiber element, we can do the same thing, but we just eliminate the need for seams or for layering.
Go ahead, Dawn.
Interesting. Thank you.
Dawn, you can go.
How much money did the company raise to date?
Yeah, so we closed a $8 million seed round for 2021 of us this past August. We had done about, I think about 3 in venture prior to that, and have about $2 million in grant funding. So sorry, it was about 2 before in grant funding and 1 in, or sorry, 2 in pre-seed, 1 in the grant funding side. So in total, about 10 million.
Thank you.
And then I see 2 questions from Josh in the chat. How is additive cheaper than high volume negative manufacturing from one piece of cloth with one size? Big component is that there is still an additive step. So you still need to go yarns to flat fabric, then you transport it to a different facility. And you go from flat fabric to cut piece. We just go direct and skip steps. So a big component of why this is cheaper is that we're reducing a lot of complexity in the steps in the process. And then privacy concerns with 3D scans. There's always a bit in any sort of new tech. We see a lot of great adoption. We already have some of the biggest brands in the world paying us for this. In fact, even the privacy element has become a competitive advantage for us. A group like H&M doesn't want to own that type of data, and they're happy to let us own it and happy to pay us every time they have a question about their customers, general morphology. So for us, that's become a really, really tactical part of the software side of our business. And yes, you do need to wear tight-fitting clothes while scanning. So like yoga pants, tight-fitting underwear, anything like that. It just uses whatever that depth sensor can pick up. And then we also have these physical in-store units as well.
Awesome. Kevin, thank you so much. That's Kevin Martin, CTO of Unspun. And looking for big things for you in the future. I think if Unspun mentioned it, but they're also interested in potential government partnerships. So anybody who is from the Air Force and is online, there's going to be a private event on January 13th. It's a good opportunity to hear Unspun pitch again. Thank you, Kevin. Up next is Fuel Gems.
So hello, everybody. Glad to be presenting. Thanks for having Fuel Gems. So we're a revolutionary fuel additive with the potential to change the fuel industry. Maybe that's a little loud of a statement, but it is the most powerful fuel additive in history and on the market. And the reason why is let's go over some problems with the fuel. So it has deadly emissions. A lot of people die from dirty air, about more than 5 million. It's about 10 million annually. So dirty fuel, contributes to that a lot. Fuel is expensive. Fuel has become more corrosive because of the additives that are added to the fuel, and because it's, getting dirty fuel, getting cleaner, better oil from the ground has become harder. So it's worse quality oil. And refineries need to differentiate fuel because it's a commodity. So next slide, please. So the solution that FuelGem has is, it's a unique nanoparticle, which when added to fuel allows it to burn much cleaner. So we reduce, for instance, we reduce unburned hydrocarbons by up to 50%. We decrease carbon monoxide by up to 15%. We decrease CO2. So we decrease CO2 by up to 20% and up to 30%, depending on how much we increase fuel savings by. And we decrease particulate pollution. And particulate pollution in soot, that's pretty dangerous because it causes lung cancer and heart disease. So other benefits of Fuel Gems, it increases lubricity of the engine for longer engine life and fuel pump life. It's very affordable. And it saves fuel. So right here we have a figure of 9% for the user ROI of up to 1,000%. But actually we just gave this additive to a client to try, a potential client to try, so they can, see if they want to buy it. And they got 18% savings on their Mercedes-Benz trucks, 18% savings on about 1.5 grams to 260 gallons of fuel. So this really is, if you compare it to cetane improvers, it's about 800 more times powerful. If you compare it to MTBE, which is not there anymore, which has been replaced by ethanol, it's about 100,000 times more powerful, because you need only a tiny amount, 1 to 1.5 grams per ton of fuel. It's a tiny amount. So the strategy here is to add this additive at the refinery level, right? And they're adding it via ethanol, via biofuel into the refining. So you get fuel already coming with this. Like Intel inside, you want to have fuel gems inside all the fuel, so fuel becomes much, much more efficient and cleaner. So you can add it via refinery level at gas stations, and it's easy for individual drivers to add it to their cars. But the best is to go to gas station operators or refineries. So next slide, please. And how does our technology work? Well, it's pretty proprietary because we design our own plasma reactors to produce the nanoparticles. So it includes hardware and software programming for the correct plasma to take place. And then we also treat the nanoparticles chemically so they don't agglomerate. It's a big problem with nanoparticles that agglomerate. But the plasma reactors, the interesting thing about it is, so we're producing a carbon nanoanion. That's our nanoparticle. But if you're going to use other carbon nanoanions, they're simply not going to work. And the reason why is it's our production method. It's a unique production method. It gives rise to unique qualities of these nanoparticles. Very cheap, really cool nanoparticles. Can be used in fuel, probably can be used in rocket fuel because we have reverse oxidation. So at lower temperatures, it decreases oxidation. At higher temperatures, it increases oxidation. And you get better burn rates, so more fuel burns, you get less emissions coming out, you get engine torque going up, and so you get more out of fuel. It basically helps it burn up completely. And so, it's pretty difficult to replicate. Well, nonetheless, we are filing, we have several patents in line. First patent, we're filing it in 21 countries, right? So we're gonna protect about 70% of countries where fuel is used. So we're not just United States, we're going worldwide. So whenever we get an acquisition offer, and we've been already approached by potential acquirers, but whenever the company wants to be acquired, it's a big plus for investors and for buyers because hey, we're protecting most of the world. Whoever wants to copy us in countries and that 30%, well, we got 70% of the worldwide market, which is 3.5 trillion. So next slide, please.
30-second warning.
Okay, so how do we make revenue? 12 million revenue from a small gas station operator, 27 million revenue from a potential refinery. So next slide. This is our customer growth. Next slide. Some of the names that are interested in our product, OMV, we got publicly traded Avastar. Next slide. So some big companies, chief scientist from BP was interested, PKA Orlen, Suncor, Ceristyle. So this is all majority publicly traded companies, CEOs, and board of directors took interest in this. So next slide. This is how much money we could make with a nice EBITDA margins. Next slide. This is with Stent. So we're very low priced and it's continuous above baseline performance for a fuel additive. There's nothing really on the market like this. Next slide, please. And so basically what we've done was we built the technology, we built a small manufacturing facility, kind of lab-based / manufacturing, but we're looking to generate about 300K, 500K in revenue and should get some big contracts under our belt and then see where that takes us, But the idea is to go big and, raise a couple of $100 million to get this into fuel worldwide. We need to set up manufacturing facilities worldwide. That's kind of our goal. So I guess, this is our pitch. And would be happy to take questions.
Thank you, Kirill. Open up the floor for questions.
So this is Rhys Schroeder. Question, has this been tested in all current, gas vehicles on the road today, or is it going to require something in new vehicles?
Has it been tested and has it? Well, we tested in numerous vehicles for the past 5 years of R&D, and it works good. So like for US market, we would need to go through EPA registration for on-road. For off-road, it can be used tomorrow. We tested it very extensively. It's safe and it works great. Like I said, we gave it to a client right now and the client got 18% savings on fuel, which is actually a huge number. It's 1/5 of savings on fuel. So if you take like FedEx, for instance, and they use it and they they get at least 10%, you know, they're spending $1 billion on fuel. That's $100 million savings. But if we take this to Africa, to Asia, to Latin America, where cars are a little bit less efficient than in the United States, it's a lot of money to be saved, and it's a lot of much cleaner air. So, yeah.
Just a quick question. How does it affect your the car performance there and or lifetime of vehicle?
Well, it increases, say the nanoparticles, they act as a lubricant. They act as little ball bearings and they increase lubricity. In certain tests that we've done, we've gotten 10% increase in lubrication to 70% less corrosive metal to metal effects. So they're going to increase the fuel pump life and the engine life. And we suspect that nanoparticles are also acting as a detergent for the engine. So it's kind of like Chevron with Techron. Techron was a fuel additive which was acquired by Chevron. So it's kind of has that effect too. So yeah, it's going to make the engine run much better.
Thank you.
Yeah.
Giving that, this is Ron. Giving that you're talking about raising a couple $100 million, it seems like the business is a straightforward kind of deal that you can do a licensing with one of the big producers instead of raising money to build your own manufacturers. You don't think it's a better way to go?
We'll try it, definitely. We'll see how the demand goes for that. Right now, we are ready actually to license the technology at this point. We've been approached to with a potential acquirer for the company, as I said. So far, I guess we'll need to run some tests with the big oil and gas companies and see if they'll say, "Hey guys, we want to license." And if they want to license, yeah, why not? You know, we can become a marketing company and get a revenue stream going of like, I don't know, $20 million per licensor. So maybe that's one of the business approaches. If not, we'll just go hardcore and we'll put up a manufacturing facility.
Okay, we have a large oil distribution here in Michigan. It's a few billion-dollar company that we should go offline and talk about introducing it to them.
Oh, awesome. That'll be awesome.
Awesome.
One thing I should note about this technology, you know, we're going into an era where there's a lot of pollution. People care about, you know, climate change finally. And this technology allows, for instance, syngas. So if a lot of companies are pulling out CO2 from the air and they're putting it into, they're making fuel out of it, or for instance, biofuel, ethanol. So ethanol carries much less energy than gasoline or diesel. So this technology brings up ethanol almost the energy capacity of ethanol to that of gasoline or diesel, right? And it increases lubricity, so you can use not only 10% of ethanol in fuel, but 50% of ethanol. The good thing about ethanol is, well, you grow plants and it absorbs CO2. So, you know, some people say, oh, you know what, fuel is a declining industry. You'll have ethanol after that, and you have synfuel after that. So, you know, if it's going to decline from 3.5 trillion to 1 trillion, you're going to have other industries where this can be sold.
Awesome. Thank you very much. And with that, we conclude our open topic. Thank you very much.
Thank you, everybody.
All right, just a quick recap. So we just heard from 5 companies. We heard first from Project Vista, Bluespace AI, Creative Battery, Unspun, and just now we heard from Fuel Gems. So with that, we move on to our first ICT session, computing. It's going to be followed by connectivity. And we are going to be joined by some additional panelists. So we'll quickly share my screen so we can see the panelists real quickly. And we'll kind of get started right on that. We'll do a brief introduction. I think we'll do a quick roundtable just so everybody can say hi and where they're from, and so that we don't get too behind on schedule. Is that okay with everybody?
Yep.
All right, so we're being joined on part 2 from TDK Ventures, Tina Tasakahawang. Yusaka Group, Hanko is continuing with us. Not Guy Zabarski, but rather we have Adi joining us also for this session. Ryan Hatcher from Lockheed, Cityside Ventures, Daron York, Kenny Vasig is joining us from Google, Deidre Williams from VU Venture Partners, John Lee from Octave Ventures, and Rhys Schroeder is continuing with us from Allstate Ventures. We're going to be hearing from 4 companies in this session: Arcs Nimbus, Edge Impulse, Tarden Silicon Systems Incorporated, and from Coherent. So without further ado, let's quickly do the rounds with the panel. Let's go as you appear on the slide. Tina, do you mind introducing yourself real quick?
Hi, everyone. Tina Tosako Wong, TDK Ventures. We are a $200 million fund, early stage deep tech in various areas such as computing, ICT, mobility, industry 4.0, clean tech, energy tech.
Awesome. And we heard from Hanko in the first session and also from Adi and Ryan Hatcher and Daron. So let's go to Kenny Visi.
Hi, everyone. I'm Kenny from Google Cloud, and my interests are high performance computing, cloud, and also I have a background in aerospace. So high tech, frontier tech type of technologies.
Awesome. Happy to have you with us. Deidre Williams from VU Ventures.
Hello, everyone. My name is Deidre Williams, and I'm with VU Ventures in San Francisco. We have 3 offices, San Francisco, Hong Kong, and New York. And I'm a part of the Frontier team, looking at space, technology, AI, those types of ventures, and just happy to be here with you guys.
Awesome. And John Lee from Octave Ventures. Johnny there. And John has joined us a little bit later on. Okay, so let's get started. Great panel and great companies. We're going to be kicking it off with Coherent, and pitching will be Roberto Di Salvo, who is the principal investigator. Roberto, you there?
Sure. Can you hear me?
Great. Floor is yours.
Okay, so good afternoon, everybody. My name is Roberto Di Salvo, and I'll be talking to you about quantum computing. Next slide, please. Okay, so quantum computing leverages quantum mechanics, arguably the most successful scientific theory of the 20th century, and it's the only known model for computing that can offer exponential speed up over today's computers. Now, quantum computers right now are in the experimental phase, and they're not available to consumers, but they're starting to work on it. Next slide, please. So before we move forward, let's look at the essential component of a quantum computer, which is the quantum bit or qubit. Now, a qubit can be an electron, a photon, a trapped atom, but also artificial atoms like transmons or flux bits. You can see an example of one there on the right-hand side. And unlike classical computer bits, qubits exist in a state of superposition, and they can entangle with other qubits, but they are very fragile and can be easily disturbed by thermal and electromagnetic noise. So next slide, please. So the challenge we have for practical quantum computing, as you can see from this image from IBM's Q computers, is that current quantum computers are large, complex machines, and qubits require a high vacuum, cryogenic, and radio frequency protected environment. And access to quantum computers is only via the cloud. Next slide, please. Okay, so what's the current state of the technology? We take a look at this image by John Martinis of Google, and it's basically a map of the qubit quality versus quantity relationship. And you can see from this image that right now, current technologies and that little black dot that's on the left-hand side of the chart. And we want to develop technology that moves us towards the right-hand side in the green area. Now, with current technology, that's going to require approximately tens of thousands of qubits with error rates of 1 in 1,000. But we believe we can do better, that we can move that green area to the left-hand side and achieve quantum computing sooner than the roadmaps that others have developed. Next slide, please. Now, how do we do that? Well, we plan to do that using topological insulators. Now, this is a new class of materials that was discovered in 2007 and received a Nobel Prize in 2016. Now, qubits made from topological insulators intrinsically protect their quantum state, and they can work at ambient temperature, and they dramatically reduce the number of qubits needed to handle error correction. Next slide, please. Now, our competitive advantage, we've been working on this topological insulator qubit since 2017, and we can read-write to the qubit using only voltage and current measurements. We don't need complex microwave technology like a lot of other applications, and the form factor and the technology is very compatible with semiconductor technology, which will enable us to develop eventually portable quantum computers. Next slide, please. Now, there's a dozen people in our team, and together with me is Alton Reich, who is a co-founder, and our CTO is Professor David Carroll. He is also the director for the Center of Nanotechnology at Wake Forest University, and he is the scientist who first started working with topological insulators and realized that they would have an application for quantum computing, among other things. Next slide, please. So up until now, we've received approximately a little over $1 million from NASA to develop these materials, and we've received 5 consecutive contracts from the Air Force to develop topological insulators specifically for quantum processors. And right now, we've received most of our funding from the government, but are working with some investors to try to get follow-on funding. Next slide, please. Now, intellectual property is very important to this. We've submitted several patent applications, you can see here on the slide, and we are continuing to apply for submit additional provisional applications as we work forward, and we intend to thoroughly protect this technology going forward. Next slide, please. Okay, so taking a look at this a little bit further from 30,000 feet, you can see this roadmap to value, and every technology that's been sort of considered as an application for quantum computing, like cryptography, finance, logistics, AI, scientific computing, and so forth, are multi-billion-dollar companies. And any application here is really the sky's the limit as far as quantum computing is concerned. Next slide, please. Now, based on market estimates, we're looking at 26 billion by 2030 in quantum computing as a service. And it's expected that quantum computing in the 2030s will reach 250 billion annually for things like cybersecurity, medical diagnostics, and all the other applications that I mentioned earlier. Now, the key here is that room temperature operation unlocks a completely new segment of the market for embedded, integrated, and deployable devices. And this is something that no one has looked at. So it's been excluded from all these estimates. And we believe this is where we're really pursuing value. Next slide, please. Now, this year, market activity has been picking up. There's been almost $2 billion invested in, like I said, this year. And IonQ has raised 600 million for its SPAC. Honeywell has merged with Cambridge Quantum, and that also raised quite a bit of money. And then Rigetti Computing is also raising money for its SPAC. So there's certainly an increasing amount of activity as things move forward and people realize the incredible applications of this technology. Next slide, please. Now, our business model is to begin with quantum cloud computing because it's the most accessible for us right now, and then work towards the local and deployable processors for mission critical edge computing applications. And that's really where the interest from the Air Force is coming. And then in the future, move on to desktop and mobile processors for quantum computing. Our financial model is looking at beginning with approximately $5 million of revenue in 2023, and then growing thereafter, reaching 450 million approximately by 2030. But obviously, this is based on our estimates. Next slide, please. Okay, so thank you, and I'll answer your questions.
I have a question, Roberto. Thanks for the great presentation. Kenny from Google. So sure. As far as using the TI technology, what prevents others from using it? I know you have filed patents, but what are the focus areas that your company is working that distinguishes you from others using the same technology, right?
Well, yeah, because it's not just a topological insulator. We've actually developed a specific crystal that has a very specific way of being grown and manufactured. And so it's not just a matter of the topological insulator. I kept it very high level, but obviously there's a lot of work in the development of the crystals themselves that are used for this application, and we're patenting the whole technology around it. So there's a strategy to protecting the IP on this on multiple levels, on the manufacturing, the technology, the systems themselves, the architecture, and so forth.
And from an R&D perspective, what is next for the next, let's say, couple years?
Right. So right now we're working on trying to demonstrate a CNOT gate, because a CNOT gate is one of the critical elements for a universal quantum computer. So we've done registers now. Now we want to do a CNOT gate, and that's what we're working on now. And we're basically trying to get money from get the phase 2 from the Air Force, but also are reaching out to investors and other organizations to try to get the funding necessary to accelerate this development.
Okay, thank you.
Okay.
My question here is along the same lines, Kenny, along the developmental line. Is your business is to scale, design the whole hardware, or do you plan to, apply this and integrate it with and partner with others to, go to market?
Right. So the beauty of this technology is that we're developing it for the processor. And because it is so compatible with silicon technology, we really don't have to develop a lot of the other technology. So one of the problems with quantum computing is, of course, you have to develop all the interface hardware layers. And the beauty of this technology is that we can basically use conventional silicon technology to interface with this. So that reduces dramatically the amount of overhead as far as the material. Or the architecture and the hardware. Now, for the software, we're developing this from the beginning to be compatible with the languages that are being developed by IBM and Microsoft. So it'll be fully compatible with their technology. So we don't really look to develop any software specifically for this. It's designed from the get-go to be compatible with Qiskit and other Q languages that are being developed.
We have time for one more question. One more question from Coherent.
Maybe what about your fundraising timeline?
Well, like I said, right now we received most of our money from the government. We've sort of been concentrating on that. We've been working with Deep-Tech, to kind of grow out from that. We're looking obviously to fundraise, definitely in the second quarter of this year to be ready to really go out and more aggressively pursue that. Right now we have some results we want to obtain, but and we're just at the beginning. So definitely within the second quarter, we'd like to be in full mode.
Awesome. Thank you so much, Roberto DeSalvo from Coherent. Up next is Tarden Silicon Systems. And pitching for Tarden will be Alan Aronoff, who is President and CEO.
Hello, can you hear me?
Yes.
Can you hear me?
Yeah, you sound great.
Okay, thank you. So let's move on to the next slide. I'll give you a brief overview of Tartan. So Tartan was founded in 2016, and we have been profitable since our inception. Our main mission is we enable our customers, which are mostly systems companies that have proprietary semiconductors, to get those devices into production and to assure that the devices are reliable and high quality. We put the chips into production. We provide capabilities through our know-how and technology and improve manufacturability and reliability of the semiconductors and hence the systems of our customers. Our business has three components in its business model. We sell productization services for semiconductors, meaning we work with customers in the design phase and through the development of the manufacturing phase from a reliability standpoint and yield standpoint, and we work with them throughout the life of the chip. We sell the semiconductors that we productize, and we license our IP. Next page. So the main problem we address is from a reliability standpoint. And if you look at the yield curves or reliability curves of semiconductors, there are three main areas. First is early life failures. Second is just the random failures that occur during the normal life of the product. And third is wear out mechanisms. And this is shown by the blue curve in the graph. Wear out mechanisms is an area of our focus because with devices today, with FinFETs and gate-all-around technology coming out, as the feature sizes become smaller, the issues of device aging will cause the transistor parameters to move around more, and in some cases may cause hard failure in a device. And this is an area that becomes more important, especially for devices that are used in mission critical applications. So, and the other key point is in the design cycle today, there are no really good means for addressing device aging through the design process and trying to simulate how the device will perform throughout its life. Next page. One component of our IP is, one component of our technology is a set of reliability and process sensors that are embedded on the chip. And our IP gets integrated onto a chip using standard design methods. And in addition, the means by which we get the data off the chip in terms of monitoring the manufacturing process of the device, as well as the reliability of the device, this is done as part of the normal supply chain flow. We do compile the data into an enterprise database that integrates the data from wafer manufacturing, wafer probe test, final test, and through the operating life of the device. And we use that database that we create so that we can apply our machine learning capability to improve the manufacturability as well as reliability of the device. Next page. So our solution will enable several benefits over current standard design and manufacturing flows. First, transistor performance and reliability are captured for each device throughout the manufacture and useful life of the device. And this enables us to achieve device traceability throughout the entire product life. And that traceability gives us the ability to monitor the device throughout its life, and also to know where that device came from, which wafer it came from, where on the wafer that device is, so we can map the capability of each device, the performance of each device, and the reliability metrics that we monitor on each device. Through the machine learning algorithms we deployed, we can identify and predict which devices that have been manufactured may fail during the useful life of the chip, and that will have an impact on the systems that those chips are used. So we are getting traction with customers who are building systems that are of mission critical nature, where a field failure or downtime has a serious cost associated with it. Next page. So this page here just shows a little bit how we're different than what is done traditionally in the industry today. Our solution provides the data history for each device manufactured, thereby enabling traceability throughout the product life cycle. We apply machine learning for manufacturability and reliability improvement. We integrate all the data that is captured from the device into a database from which we can apply our machine learning algorithms to improve yield and to predict failures. And it provides a mechanism for monitoring the health of the device and the systems that the device are contained in throughout the useful life of the system. Next page. This just shows the founding team, myself and Chakra. We both have over 30 years experience in semiconductors and systems work. My expertise is in semiconductor manufacturing design, and Chakra has a big history in AI and data science. Next page. So the key milestones that we achieved in this past year is we did complete the fundamental developments of our technology, and we have filed 2 U.S. patents. There are 2 more planned, but we've completed 2 patents filed this year. Those patents cover our sensor technology and the methodologies that we employ for managing the silicon life cycle. We've expanded a relationship with a key partner, that would be Siemens. And as part of that partnership, we have, well, there are a number of areas we're working together. We have shown some of those areas in a joint presentation we did at the IEEE test conference last October. And the third item is we have just recently closed a manufacturing deal with a major optical networking company. And this is basically providing a validation of our services and also of our business model. We have, since this agreement was put in place last month, been successfully delivering high quality devices to this customer. Next page.
30-second warning.
Okay, so for our growth, we are focusing on some additional investment that could come either from SBIR projects, NRE work from customers, but we're also looking for a little money outside, $500,000, so that we can expand our current semiconductor production business. The million looking for as an investment or SBIR project, this will enable us to put our sensor onto the industry leading edge of process technology. Any questions?
I have a quick question
So
here.
you put on sensors, but do you also then have to add some little microcontroller to read them out, or do you then interface to the system on the chip to do it, and they read your sensor?
Well, our sensor basically interfaces with the CPU bus architecture in a digital chip. The sensors are what we measure is inherently an analog signal, and we do convert that to a digital set of values that could then be read out through a digital system.
Question here. Actually, I think that this is a perfect marriage between semiconductor production and data science. I really like that, actually. How much you raised so far?
We are self-funded. We've raised zero money. We've been profitable from the inception, but we've been able to grow primarily through development and production agreements that we've put in place.
Now, I know you're closely working with the NEC, right? I mean, the Siemens, right? I know you used to be with NEC, I guess, right? But have you in touch with any other companies?
Yeah, we're talking. Yeah, we have a number of partners that we work with, and maybe I could have expounded on this. We do have a major partnership with ASE, the #1 semiconductor assembly house, or maybe they're #2 now, I'm not sure. We have a partnership with a European company called Synergy CAD. They basically provide hardware for test and reliability purposes for us. And we also have a close working relationship with a data mining company called Galaxy Semiconductor.
That's also wondering about. You have the data mining part. It could be a great business model down the road, actually.
Mm-hmm.
Thank you. Maybe we can talk later. Thank you.
Sure.
Go ahead, Ryan.
So interesting. I got a question about actually ASE. Very interesting that you're working with those folks. So one of the big issues that we have is looking ahead at the system and package, the migration from SoC to system and package, and advanced packaging is being critical to fielding next generation devices, integration of analog, cellular analog devices, integration of analog optical devices, 3 5s with your silicon, with your memory, all in the same package, not board level. Are you going to be able to, have you looked at this? So one of the maybe the biggest challenge is the known good die problem.
Right.
Is that something that you think you could address with your, so the known good die problem, meaning you source a bunch of chips from different vendors, different providers, OEMs, and then you have to like assemble them. If one of them is bad, the product is bad. Who pays?
Right.
It always goes down to who pays.
Right. So there's a lot of work around that that has been done to date. Probably the simplest thing to do is to wafer probe each device so you know what is good. And if those devices had our IP embedded on it, we would also be reporting out certain transistor and passive device parameters based on the manufacturing. And with the reliability sensor, well, it doesn't make sense, to measure your reliability sensor at time 0, other than it sets a baseline so that as the device ages, the sensor measurements will vary. And that's partly where we apply the machine learning, so we could look at that variance and match that against devices that we've that we've aged and subsequently devices have failed. So we can, that's basically part of how we do the failure prediction. So the known good die issue will address, your failures at time 0. And you can solve that pretty much with a wafer probe. But then you have the other issue of devices are going to age, devices may fail in time. And if you have n number of devices, their independent variables are all going to have their own probabilities of failure. You still have a problem. And at least with our technology, we can help monitor how that is progressing and what kind of problem you may face.
Awesome. And one quick question too. Sorry, there's just are you married to any of the specific TCAD tools? Like, do you only work with Cadence, or do you only work with Synopsys?
No, we're
agnostic.
independent. We're independent of that. We've done some of the work we've done. We've used tools from Synopsys. We've used tools from Siemens and Cadence, but we're in essence we're agnostic in that regard.
Thank you.
Awesome. Thank you so much, Alan.
Thank you.
Next up, we got Edge Impulse. Pitching is Sheena Patel, still in the deck.
Hey everyone, happy to be here. Appreciate your time today. So my name is Sheena Patel. I'm a sales executive and I handle essentially business development for Edge Impulse. So next slide, please. So Edge Impulse is essentially we are the leading solutions provider of embedded machine learning. And what that really means is we've been talking a lot about edge computing. It's essentially the same thing.
I got a haircut appointment at 1:30. I was going to go pick up your stuff.
Oh, so I think someone needs to go on mute. Yeah, so like I was saying, we are the leading provider of these solutions. And when we talk about embedded machine learning, we're really talking about bringing that intelligence from the cloud directly to the end devices. So think of anything from MCUs to microprocessors. You can even think of a mobile phone as the edge as well, or some sort of gateway. And so what we're doing is not trying to completely eliminate the cloud at all. We actually have a lot of customers that essentially are figuring out what makes sense to run on the cloud, what is a lot more computationally intensive, and what are the things that we can actually bring to the edge to do basic, to add in basic intelligence. And so, like I said, we provide solutions, and we're basically built on top of a software as a service platform, which you can actually see an image of here. Our customers today pretty much span across industrial, automotive, consumer, and today I'm really excited to be here. We're going very heavy into government and DoD. We already have some traction in this area, and it's something that we really want to double down on next year. And to really just summarize what it is that we do, anywhere that there are edge devices that are collecting sensor, audio, vision data today, a lot of times that data just kind of gets lost, especially if there is not ready connectivity to be able to send that data up to the cloud and process it. And so our main goal is really to help customers to take advantage of that data, to create better products that have improved user experiences, can really help some of these product manufacturers monetize that data and build enhanced features. Next slide, please. And so I just wanted to show this slide. A lot of times people kind of wonder what are some of the specific use cases. And, this is not an encompassing list by any means. It's just meant to kind of get some creative juices flowing, give you guys an idea of some of the applications we're really starting to see and where we're starting to see the trends in this edge machine learning space. And so, I won't hit on every single one of these, but I'll just highlight a few. So the one that I wanted to talk about today is actually worker health monitoring. So this is a really big area we're starting to see a lot of. It's actually one of Edge Impulse's really strong suits. We work with some of the top wearables customers in the world already. And essentially you can think of it as adding more than just step counting or tracking how many calories are burned, right? It's going to the next level and actually taking some of this biometric data, some of this motion data, and being able to derive even deeper insights. And so we actually just completed a pilot project with a company called Slate Safety and sponsored through the DHS, where we were actually looking at firefighters. And today firefighters, a lot of them actually get injured out in the field through overexertion and heat exhaustion. So we worked with this wearable company to basically take the data they were already collecting and develop an algorithm that would run directly on the hardware for heat exhaustion. So now when a firefighter or first responder is out in the field, it actually can notify them prior to them actually, collapsing or becoming overexerted. And so that's just kind of an example of some of the things that we're starting to see. And as you can imagine, this doesn't just only, it's not only relevant for government or DoD, it's really across all industry. Think of factory workers and monitoring their health as well. Another area that we're really starting to see, environmental and gas sensing over here on the right-hand side, and really adding some more intelligence to your traditional sensors from an environmental perspective. So one of the use cases we recently worked on was for improving smoke detection and smoke detectors. One of the big problems that the customers in this space are actually facing is a lot of false positives when it comes to detecting when furniture or a part of a home is actually burning versus somebody's cooking or taking a shower. So we actually applied machine learning to this problem with the goal of actually running the algorithms directly on the smoke detectors themselves. And we were able to develop pretty accurate algorithms. So at the moment now, we're actually working with some of the top smoke detector manufacturers in the world around actually implementing machine learning for some of these problems. And so this just gives you a very high level idea, but across the board, we're seeing these applications on the commercial side, which is really where Edge Impulse started as a company. And we're starting to see it more and more on the DoD and government side as well. So a lot of overlap between some of these applications. The great news is we already have experience in a lot of them. And so we can really, work with customers across commercial and DoD and help accelerate the speed of how quickly we can validate and then develop these solutions.
30-second warning.
Yep, next slide. So here's our traction today. Like I said, we're really heavy already on the commercial side. Here are some of our customers. We obviously can't display every single logo, but these are just kind of giving you an idea of some of the areas that we're already playing in, the hearable space, the wearable space. And then we're also starting to really go heavy on smart factory, intelligent healthcare and things like that. We actually have already secured a pretty decently sized government contract through In-Q-Tel. It's with a 3-letter agency, so we can't really disclose the logo, but this is an area that we're starting to see a lot of potential for. And so really, the call to action today will be anybody in this space, either a commercial enterprise or on the government defense side. If you're looking at embedded machine learning, please contact us, let us know. And then overall on the funding landscape, we actually just closed our Series B. That was a $34 million round led by Cotu. And so, that's really, that funding is meant to kind of accelerate the pace at which we can grow in this market and how, and some of the sectors we can start going into, including defense and government. Okay, next slide. And yeah, feel free to reach out. So if you're a company, if you're in government defense, if you're just exploring embedded machine learning and you think that there might be some value to looking at these solutions, please reach out. We also work really closely with our partners. So think of anyone who's a professional service provider or you're a system integrator, you're looking to add new capabilities to your offering already. We actually work pretty extensively with partners in this space and on the silicon provider side as well. So we're starting to see a lot more neural network specific processor architectures, very specialized devices. And so a lot of our partners actually are working directly with us to enable their customers to develop these solutions that will run on, specific, either general purpose or more specific silicon. And so here's my email address. Feel free to contact me, reach out, and we'd love to have a conversation with you. Thank you.
Hey, Sheena, this is Rhys Schroeder from Allstate. I see bunch of companies every day talking about AI, machine learning.
Yep.
But you know, I don't always think about like what's embedded underneath. And so just a question for you, I understand what you do. Who are your like key competitors in this space?
Yeah, so what we actually see is a lot of customers today are trying the do-it-yourself route. And so what that essentially means is looking at a common ML training platform. Think of like a TensorFlow or PyTorch, which really requires a lot of data science and machine learning background. And so what we're actually seeing in a lot of customers we talk to who actually come to us is they started off with a data science team actually handling all of the ML. And then when they want to run it on the hardware itself, they basically throw it over the fence to a team of embedded engineers. Think of like electrical engineers who actually know nothing about data science or ML. And they're like, okay, fit this on a microcontroller now and make sure it still runs efficiently, it's low power, it doesn't take up too much memory. So that's actually what we see a lot of customers doing. What we've done is basically create an end-to-end pipeline that avoids all of these kind of miscommunications and issues that happen between an ML team and an embedded team that we see in a lot of our accounts today. So I'd say that's one of the biggest routes we actually see customers doing, like trying to just do it themselves and realizing that it's a lot bigger of an effort than they previously thought. So yeah, that would be my answer. Mm-hmm.
Thank you.
Yep.
Sorry. Yeah. Along the same line, have you done a comparison on the power consumption between your algorithm and others in the market?
Yeah, so one of the great things about our platform, and so I kind of alluded to this, we are the experts in this space, but we build on top of this platform, which is designed specifically for embedded deployments. And so as somebody is, either they can work with us directly and we'll help them really like utilize that platform to speed up their development, or there's an option they can just, if they have a really strong development team, they can just use the platform themselves. And in that platform, it actually provides things like, memory usage from a flash and RAM perspective. It also tells you about, this is the latency required for this algorithm to run given your specific hardware. And from that, you can actually determine power consumption. You can kind of estimate it just based on those numbers. And like I said, like we basically partner with all of the big silicon vendors in the market today, including TI, Nordic, Scilabs, NVIDIA. So we have all of their chip architectures designed into the platform so people can actually estimate all of these parameters as they're developing their algorithm.
So you already have traction with Homeland Security and IQT, right? You said?
Yeah, so we just completed a pilot project with the DHS around firefighter heat exhaustion. And then, yeah, like we do have an ongoing contract through In-Q-Tel.
Okay, right. Thanks.
Yeah.
My question here, hi, Sadi, trying to understand kind of your competitive edge, because these sort of companies on edge, these kind of mitigators of mostly to industrial and other kind of companies that don't have the specialty in modern deep learning. So kind of trying to understand, so what's special about your solution and not, you have TF Flight, you have like stuff and you have all the kind of the chip manufacturers, they also have these tools and they assist you. NVIDIA will be happy to assist you on their Jetson and everything. So kind of what's your kind of secret sauce that you can share?
Yeah, sure. So some of the big things that our customers really love, and I think it sets us apart from definitely like the do-it-yourself route. So the platform is pretty low to no code, which enables anybody to essentially come in and develop some of these algorithms. It usually required a data science or machine learning background. And not to say that this is not a tool that can be used by ML scientists. We definitely have a lot of other features built in around data ingestion, data management, and things like that, which the more data science people, those are the features they use. But if you think of like an electrical engineer or embedded engineer who writes firmware code, it's not an area that they're really an expert in. So I think the low to no code part is really appealing. Everything is transparent. We don't black box anything. So basically we provide a user interface, but then there's code that underlies every single aspect of that. And so, if you want to go and touch the code directly, you can do that. And at the end of the entire process, what we give you is a C++ or Linux library, depending on whatever build environment you're using. You can actually parse through that code. You can see exactly what different functions are happening from the signal processing or machine learning standpoint. So we try, I mean, our goal is to not hide anything. And that's a fully licensed library to whoever, is using the platform. Whereas like there are some edge machine learning platforms out there, they kind of just tend to black box whatever solution they give. You just put data in and then you get an algorithm out. You have no idea what happened in between. So I would say the low to no code and transparency aspect are really appealing. And then the final thing I'll say is the flexible deployment. And so the idea is you develop an algorithm, you may not even know what hardware architecture you want to deploy to, or you want that flexibility. It's really simple in our platform. You just choose whatever silicon target, or even if you want to deploy to a mobile phone, you can do that. And essentially whatever algorithm you develop can then be deployed across kind of any end target hardware. So I'd say those are the three big things.
Okay.
Hello, this is John from Octave Ventures. Quick question on your pricing model. How are you guys doing the pricing model for the commercial customers and also for government customers?
Yeah, so those are a little bit different, just because with the government customers, we kind of have to understand what their specific needs are. So just to give you an idea on our government contract right now, we're actually kind of functioning, we're not truly a prime, but we're functioning as one where we've subcontracted out parts of like hardware development because it's not really a focus area of ours. Firmware integration, things like that, we'll probably subcontract out. And then in some cases, we might bundle like solutions, packages, labor, things like that. On the enterprise side, it's more of a licensing model. And so I can definitely, if you're interested, more than happy to set up a call and kind of talk through that model with you. But at the end of the day, we are a SaaS platform. And so however we choose to bundle that for the government versus enterprise customers, it generally does kind of have that recurring revenue aspect.
Okay, great. Let's do that.
Okay, awesome. Thank you guys.
Awesome. Thank you, Sheena Patel from Edge Impulse. Next up is Arx Nimbus, and pitching will be David Moon, CEO.
Thank you, Josh. We're Arx Nimbus, the mathematics of cybersecurity. Our mission is to bring complete transparency and governance to cybersecurity risk for every organization worldwide. Next slide. We track attack probability and a monetary impact forecast. We're the only solution in the cybersecurity space today that is able to characterize risk in financial terms using actuarial science models, data science, and historical data losses as well. This allows companies to determine how much to and where to invest in capabilities to reduce risks and recover costs, and produces a comprehensive level of preparedness for regulatory compliance and litigation defense. Next slide. We're raising $4 million on a valuation of 20, primarily to fund our marketing program. Next slide. We're now at the forefront of risk valuation, and one of our first customers was US Stratcom. Stratcom had a difficulty in determining the risk reduction potential of commercial solutions. So we worked directly with Stratcom, MITRE Corporation, Johns Hopkins University, and KBR on developing that initial model, which is now protected by patent. We have worked with the insurance industry. Our original economic model was developed at the Department of Economics at University of Chicago, and we've worked heavily with AT&T. We are a complete SaaS solution, fully secure and scalable on Microsoft Azure. We've been reviewed by the Society of Actuaries. We have a formal collaboration agreement with the Department of Actuarial Science at University of Illinois and a ServiceNow partnership. And we were just named last month as one of Pepperdine University's most fundable companies. Next slide. The market size for the cybersecurity solutions market, as you may be aware, is $178 billion a year. Our market within that is risk compliance and threat analytics, and that's an $8 billion market slice of that $178 billion overall market. Our TAM is represented by cyber risk analytics, which is about 33% of the overall $8 billion segment. Our 2025 plan calls for us to capture 1.5% market share of the current sub-market segment. Next slide. Some of the market dynamics here are quite interesting. You may have noted, since we're in what I believe all of financially oriented backgrounds, that Chairman Jay Powell yesterday identified cybersecurity risk in his prepared speech as the largest risk and the one that concerns him most. Here's a deep dive on the part of Swiss Re in a survey of senior management, which showed that about 90% of senior management believes that cybersecurity risk is a direct risk to earnings. And yet, out of the same group, 80% of them said that they have no insight as to their own cybersecurity risk. So clearly, this is a gap issue to be solved. Next slide. We're one of the top 500 cybersecurity solution vendors worldwide, according to Momentum Partners in their annual Cyberscape survey. Next slide. And we've been covered by Gartner as the leading solution in digital risk management and data-driven risk management. Next slide. We have outstanding testimonials, including from Mark Roth, Chief Engineer of the U.S. Air Force, Marisource Bergen in the lower left corner, major cloud providers, as well as Nist themselves. Next slide.
1 minute warning.
The solution provides total digital risk that the enterprise throws off, as well as how much of that risk has been mitigated through current solutions and how much has been transferred through cyber insurance programs. Next slide. We use visibility data from 360-degree sources, including proprietary sources, some published sources, et cetera. We do scans. None of our effort requires us to be on the ground. All of this is done through data. Next slide. This is just kind of the process flow for implementation. Next slide. This was a recent implementation that we had with a $170 billion company globally, operating in 120 countries, 48,000 employees. They had one of the big four in to develop a model of their PII breach risk exposure, which yielded an estimate of 25 million. Like most work that's being done currently in these outdated models in the cybersecurity risk management space, this was highly dependent on professional opinion and expert judgment. We came in and then, based on data, we're able to show them that their actual risk exposure was around 192 million. That's an 87% delta, and this is very typical of the kind of results that we experience. Next slide. So another case study, total enterprise cybersecurity risk was 368 million. This was a financial institution. Their cybersecurity budget, 30 million. Basically, the cost of the solution in their case was 230,000 a year. And again, it's a SaaS subscription solution. Retargeting their gains in risk reduction produced an additional 8% cost recovery. And that resulted in 21.5 million a year, resulting in a 93 times ROI. Next slide. We've got substantial traction with a wide variety of customers, including alliance partnership with Tech Data, ServiceNow, and others. Next slide.
And that's time.
Okay, next slide. Just competitive advantage. Next slide. Team. Next slide. And that's it. Thank you.
Awesome.
And questions?
Thank you, David. Open up the floor for questions.
David, what was your planned use of proceeds on that 4 million raise?
It's primarily marketing and biz dev. And to date, we have really invested since our founding in 2016, primarily in the product. As you might imagine, it's a highly technical product. I should mention our original CTO was the former CTO of Tesla Motors, Gene Glaudel. And so we've made great strides on the product front, but now need to raise additional capital to properly address the market.
What sort of revenue do you have to date?
We've just crossed in 2021, $500,000 a year ARR.
Thank you.
Go ahead, Rhys.
Sure. Hi, this is Rhys Schroeder from Allstate Strategic Ventures. David, just a question for you, and I asked this of various, enterprise cybersecurity software or companies that I come across, but the attack vector has really changed since COVID, and everybody's working from home and whatnot. Is your solution, able to address, all the way down to like the router in my house as far as the enterprise risk?
It is. We operate on the basis, Rhys, and by the way, greetings from Chicago. We operate on the basis of controls and validation of controls. We can do that at a variety of levels, including a global agreement that we have with Crow, the accounting firm, to establish controls at a very detailed level. We use the Nist 800-53 framework, or alternatively, quite a bit in SMB space, we use Nist Csf, and we also can use ISO 27001. As you may be familiar with those frameworks, they cover everything from network, server, storage, cloud, edge computing, Internet of Things, shadow IT, et cetera. We include that entire landscape, and most conventional risk management systems include primarily the glass house or corporate data center, if you will.
Thank you.
Awesome. Thank you, David, so much. That wraps up our second session.
Wonderful. Thanks, everyone.
All right, so quick recap of this past session. Here we go as we get through it. We saw 4 companies pitching in the computing session: Arcs, Nimbus, Edge, Impulse, Tarden Subon Systems, and Coherent. We were joined by a great group of panelists. I'll skip the goodbyes because many are continuing with us. Thank you if you are, if you have to drop off for whatever reason, but you're more than welcome to stay on. And in the third session, connectivity, we'll be joined by Shield Capital's David Rothstein, Shintaro Kano from Shimizu Corporation, Frank Levinson continue with us, Tina Tasakawa is also continue with us from TDK Ventures, Hanko from Yusaku Group. This is D, of course, from Sabra Capital, and Rhys Schroeder is continuing with us as well.
I'm dropping.
So Adi, thanks for joining us.
First session. It's fine.
Appreciate it. Thank you. Just maybe opportunity for our new panelists to quickly introduce themselves. Maybe David, you could introduce yourself.
Sure. Hi, David Rothstein with Shield Capital. We're a new venture fund focused in dual-use technology space. I think everybody on the team is a veteran. Also, most of the team has been successful founder or worked in finance, and spent 13 years in the Air Force. Just recently came off active duty. So looking forward to today's presentations. Thanks.
Awesome. Thank you so much. The rest of the panelists continue with us from the previous session. Pitching today, we're going to hear in this third session on connectivity, Zenesys, Orbweaver Sourcing, Connexio Cloud, and Symet Corporation. So let's kick it off. Pitching for us is Symet Corporation, and Jeff Sather, who is the VP of Technology and Customer Solutions, will be presenting.
Monty Johnson, CEO. I'm going to start off with the presentation, and we'll have Jeff for questions right afterwards.
Oh, perfect. My mistake, Monty. Go ahead.
No worries. Thanks for the opportunity to talk about Symet's unique technology that addresses the power needs of sensors for medtech and cold chain. We've had years of development in this technology, and we're looking for investment to take this over the goal line. Next slide, please. Symet is a recognized leader in solid-state thin-film micro battery technology and products. We've got a high-volume manufacturing in place in Lubbock, Texas, with our partner XFAB. It helps protect our strong portfolio of patents, trade secrets, and a key thing is know-how. Our product is the interchip. serving high growth markets in low power IoT, smart sensors, biomedical applications. It's really meant to replace conventional power sources with solid state batteries, thereby having rechargeable, safe, miniature batteries that can easily be integrated into end products. Next slide, please. Manufacturing process is very similar to that of many semiconductors. The batteries are fabricated on silicon wafers using photolithography. The small size of the micro batteries can be used by customers as bare die, chip scale devices, integrating them into products where the attributes of safety, high cycle life, low self-discharge, and miniaturization are critical to the product design and use. Inner chips are reflow solder tolerant, which means they can be deployed using high volume, low cost assembly tools and methods. Next slide, please. So what differentiates us? Conventional batteries and supercaps, they're bulky, they're unsafe due to liquid chemicals that can leak, often flammable, and require holders or sockets for physical and electrical attachments to circuit boards, placement into enclosures, etc. The inner chip overcomes these issues, and Symbit's developing high capacity, high density, which we call HD versions of the inner chip in order to expand the addressable market in key applications. Next slide. There's many markets and applications available to this product, including wireless sensors and data logging, such as in cold chain monitoring, semi-passive RFID, miniature, low power medical sensors, and IoT generally. You can see the market growth, and I think many of you on this call are well aware of that. So I'll move on to the next slide, please. Symbit's been working with several biomedical device companies, particular in biosensor, neurostim, and in particular ophthalmic applications. And the reason for that is because of Interchip's unique size, biocompatibility, non-cytotoxic nature, and the options to integrate these into medtech product designs. Again, the real small size allows them to be integrated quite easily. Next slide. HD of the Interchip will allow a game-changing application in the cold chain marketplace as an example. We've demonstrated a 2-chip IC plus Interchip battery that can be deployed on a low-cost, flexible, disposable RFID sensor tag. And this would allow for a huge market opportunity as it overcomes the impediments to that market right now, which is size and cost limitation of current sensor tag products. In collaboration with IC circuit design companies, we're developing this technology platform that can be deployed in many supply chain environments, monitoring perishables, food, pharma, biologics at a very granular level. The measuring and logging temperature provides continuous end-to-end information, which heretofore has been very difficult in the cold chain. Next slide, please. As noted before, our interchip manufacturing is done in the US in partnership with X-Fab Texas, which operates a large wafer fab in Lubbock. The battery wafer fab is isolated within the larger fab and is operated and managed by trained, experienced X-Fab personnel with oversight and guidance by Symbit. This operation helps us protect our extensive IP portfolio and allows for our HD R&D activities to occur largely in that same facility. Next slide, please. Symbit's looking for investment of $2 to $6 million to help us get over the goal line here. At the low end of the investment, the minimum amount needed is $2 million to get this HD development moving forward. And that's both the 2X, which is what we're currently working on, and the 4X, which we're doing some developmental work on right now. Also, the HD plus the sensor tag product development, which includes the ASIC design, tag integration, business development, would take 18 to 24 months, and we would need the upper end of that range. Next slide. The Symbit leadership team has a lot of experience in technology. Our CTO, Dr. Downey, is well-versed in and probably more knowledgeable of solid-state microbatteries than anybody else in the world, as is Jeff Sather, our VP of Technology and Customer Solutions, who's also on the call here today and certainly can answer any technical information that you might desire. So with that, I'll wrap it up and see if there's questions.
Yeah, actually, I got a question here. I'm sorry. If you don't mind, I'll just go first here. Yeah, I know the solid state batteries main disadvantage is the basically, I mean, manufacturing at a large scale, right? But it sounds like you're working with the X-Fab in Texas. You solved the problem. Is that correct?
Yes, that's correct. We started quite a few years ago. We started development of that, where they contributed some equipment. We contributed the key customized, which is the cathode deposition tools and the lip-on, which is the solid state electrolyte deposition tools as well.
Oh, great. Yeah, that's great. Congratulations. Thank you.
Thanks. What's the voltage, the watt hours, the simple dimensions of the battery, just, you know, so that.
Sure. Yeah, hi, Frank. The battery voltage is 3.8 volts on the output. On the discharge side, it's a 4.1 volt charge voltage. The typical dimensions are anywhere, well, we've made them smaller than 1 millimeter on a side, but typical dimensions are 2 by 2 millimeters up to 6 by 6 millimeters XY footprint with a thickness, a typical thickness of 0.2 millimeters. And that includes the hermetic seal that we apply as a wafer level encapsulant. The capacities typically measure in the tens of microamp hours capacity, and they're rechargeable many thousands of times.
Thank you.
Mm-hmm.
For one last question, if we have it. All right. Well, thank you very much for the Sinbet Corporation team.
Thank you.
Thank you.
Moving on, next up is Connexio. Pitching will be Billy Shaheen, CEO and founder.
Awesome. Thank you so much. Pleasure to be here. My name is Billy Shaheen. I'm the CEO and founder of Connexio Cloud. We are an all-in-one unified communication as a service, customer engagement, and workforce management platform. Next slide, please. Our team ranges of 40 individuals across 4 countries. This team consists of developers, support, client success, sales, and marketing, and our seasoned executive leadership team with over 50 combined years of experience in the industry. Next slide, please. In 2014, myself and a couple of the other founders were running various businesses. We scaled an operation up to 3,000 plus employees in 5 countries. Due to limitations in the industry, we ventured to build our own solution for our own needs. This became a great business. We brought it to market 2017, and 2021 we sit here. Connexio Cloud was born as well. We're completely bootstrapped, no outside investors, 100% founder owned, and we have 5+ successful startups and exits between the founders. Next slide, please. The problem and the need that we're solving, high availability, self-serve, omni-channel communication tools and contact center software, automated and efficient onboarding and workforce management tools as well. So we focus on communication and workforce optimization tools. Next slide, please. Our solutions are a full suite of workforce management and communication tools. We range anywhere from programmable IVR and call menus, a CRM, universal communication, contact center software, PBX and telephony, dialing platform. We have pretty much anything that a business needs to run their communication or their workforce management side of things. Next slide, please. Our core technology is built on a proprietary PBX and telephony infrastructure. Everything that we have, we hard-coded high-level management logic for automation and proactive management into the software. We also have a proprietary cloud management platform for deployment and automation. There's no open source backend remains within our platform. Next slide, please. Industry applications range from a wide range of industries. Finance and fintech, hospitality, retail, healthcare, BPO and call centers are a big solution for us. Real estate, customer service, sales and marketing, and more. Next slide, please. Our competitive advantage is really pretty simple. We're able to take an usual fragmented tech stack and consolidate it down into one platform. So we take 3 to 4 usual providers, consolidate it down into one provider being ourselves. We're able to save money, sometimes as much as 50% for these companies, and we're able to give them one consolidated package as well. Next slide, please. Taking a look at why we do what we do, the cost of communication, what we've seen is missed calls cost money. So if you're not able to have a high availability self-serve solution for your customers, simply put, they'll go somewhere else to do so. Every call costs money. So we take a look at, breaking down an attorney, $40 per missed call. You can take a look at different industries, take a look at something like a suicide prevention hotline. The cost is a lot higher if they are not available for the communication. Next slide, please. The self-service communication tools are very important. 9 out of 10 customers want to speak to a business using messaging. They prefer that channel already. And from a business's standpoint, there's a lot of value being able to give people self-service tools. An agent-assisted interaction is going to cost anywhere from $6 to $12, depending on what your cost of labor is. Self-service is going to cost 25 cents to $1, depending. Next slide, please. Our automation focuses on eliminating daily tasks. So we eliminate busy work, help give that time back to the organization. And if you quantify that out, we help save businesses money. Next slide, please. Our total addressable market, about $145 billion. There's a little bit of overlap in some of these areas, but we realize that overall, we have a very good shot at getting a little bit of a market share in a wide range of these. Our gross margins are 90% and our operating margins are 85+%. This allows us to return equity back to the shareholders. Next slide, please. Our current traction, we have about $4.5 million in yearly revenue, 1,000+ worldwide customers that are satisfied. Key partnerships with Salesforce, Amazon, AWS. We're in their app store to bring communication tools to their existing customer base. Next slide, please. Our ask is really pretty simple. We like to think so. We're really looking for strategic partnerships with brokers, clients, and networks to bring our technology to market. We offer very aggressive partner and residual referral payouts for the lifetime of the customer. And we're looking for an investment opportunity currently to raise about $3 million. So with that, we plan to reinvest in sales, marketing, customer acquisition, and really just bringing our product to market. Because of our high margins, we're able to return a lot to investors and really make it worth their time in getting involved with us. So that wraps up our time. I'll turn it over to any questions. Thank you for your time today.
Go ahead, David.
Hey, thank you, Billy. Curious, you mentioned a lot of different use cases. Which industry have you seen the best traction with? And then also, could you talk about retention? How often are people renewing?
Absolutely. Great questions. We have partnered up we've partnered up with a lot of BPO and outsourcing companies. So the companies that are handling multiple campaigns for several different companies, think about, the Accentures, the Sutherland Globals of the world that have a lot to maintain. So our best use case is a call center situation like that, because we're able to really give them all the tools that they need, not only on the communication side, but the workforce management side of things. So within a call center, the attrition is terrible. There's a lot of churn with new employees. So we gave them tools such as the automated onboarding features, to help them automate some of their, things that they're spending a lot of money on and a lot of time on. So I think that, drilling down into that specifically, insurance, real estate, any sales and marketing organizations, very wide range, finance as well, banks. We do a lot on the programmable IVRs for security and things like that. So the long-winded, answer on that side of things. And the retention really has been pretty phenomenal. I like to take a view on things. If you have a customer for one part of their business, the churn is going to be a little bit higher. If we have multiple parts of their business, which we tend to do, if we have their CRM, their call center management, their IVR and call menu side of things, 3 or 4 different pieces of their business, it's very hard for them to leave. Not only that, but they're always very happy with our business. Biasly speaking, we give the best technology and, we give the best support in the industry as well. So, we've had a lot of positive feedback. That $4.5 million a year in revenue, we spent 0 marketing dollars on. It's all word of mouth. People loved our product. They loved, working with us, and, they've referred us customers and stayed with us pretty much for the lifetime.
Great. Thank you, Billy.
Absolutely. Thank you.
A quick question here. So just 2 quick questions here. So I know your product is based on PBX and telephony infrastructure, right? And you mentioned that there's hard-coded high-level logic, right? So did you find any approach, and as in in future update or innovation, maybe how it's going to be done easier compared to other method, or just curious? I don't know exactly your technologies, but sounds really fascinating. That's all I was want to know more, learn more about it. So
yeah, absolutely. We were lucky enough to have some very high level people involved with us from the very beginning. So we had a couple gentlemen with us that ran big BPOs for Ameriprise, big companies that were running, anywhere from 8 to 12,000 agents on the floors at times. He was managing 75 managers that were managing, indirectly those, those employees. So what we did is, before we built anything, we took a look at, not only his needs, but our needs coming from the industry. And we took a look at like, hey, what do we need from that standpoint? How can we give ourselves time back? How can we give ourselves efficiency back? How can we eliminate human error from in a situation with 10,000 humans in it? If you eliminate a little bit of human error, it makes a big difference. So we started from that aspect, and we did everything in that regard. So rather than going in and pulling a report, we sit down with the customer and we understand, when do you need those reports? Where do you need them delivered? We automate those processes. So we help give them back that time. We have a lot of proactive management tools that help be their eyes and their ears within the call center or within their situation. So proactive management tools, and a lot of things that I think just extend past being just a software provider. We try to really give them tools for what we felt the industry needed. So we're constantly looking to innovate. In 2014 we built a mainly phone system. In 2016, 2017, we saw the industry shifting, and we started building what is now Connexio Cloud, which is a full platform, full communication. So we stay paranoid, we're always innovating. We're always looking for the next, where we see communication going, where we see the next area going. So
maybe you can tell me a little more about a pricing model later, okay? Because I don't want to take up too much time here. So thank you.
Absolutely, I'd love to connect.
Okay, Frank, did you have a question? Is that from the previous session?
No, previous.
Okay, good. So thank you so much, Connexio and those Billy Shane pitching. Moving on to our next session, pitch is the second to last pitch. It's OrbWeaver sourcing, and pitching will be Tony Powell, who's co-founder and CTO.
Very good. Thanks, Josh. You can jump right to the next slide. So we are OrbWeaver. My objective here today is to just give you a quick intro to the company. We are looking for partners for a small Series A, and of course, we're always in the market for opportunities to apply our technology. Next slide, please. So we are in the business of making supply chains, and in particular the electronics manufacturing supply chain, more efficient. Right now, and you see this everywhere, if you're trying to buy anything, the supply chain is very, very challenged. And the root cause is that management of supply chain data is slow and very opaque. It is slow and opaque because it's largely done by human beings. And that data then becomes trapped in emails and in phone calls and voicemails and text messages and things like that. The symptoms of that core problem are lack of transparency, a lack of resilience, which is to say the inability to react to supply chain challenges as they arise, very, very high transactional costs, high error rates, and all of this really boils down to minimal control. Supply chain processes are arbitrary. They're essentially a function of how employees choose to process an order, either receiving or sending, which is to say they are not institutionalized, they're not programmatic, they're not easily repeatable and scalable within a business. Next slide, please. So, and of course, Orb-Weaver is the solution. We are a modular B2B SaaS provider focused on solving the problem of getting companies in the electronics manufacturing supply chain connected. We started out doing this based on decades of prior art. We didn't just start cold. We went and looked at everything anybody else had done prior. That includes EDI, EDIFACT, CXML, scores of APIs, anything we could get our hands on. We used as a basis for this to try to understand what the root problem was in this digital communication of supply chain activities, which is to say the buying and selling of parts in the electronic manufacturing industry. So we came up with a set of products. DataHub is our core technology. I'll focus on that one. The other 4 products we can talk offline if there's an interest. Those are buying and selling tools that are built on top of the core data transmission technology. Next slide, please. So DataHub is really our solution to this problem. And if you think about the problem is a conversation. People right now in buying parts through almost any supply chain, really, we are focused on the electronics manufacturing supply chain, but this is broadly applicable. It is a human conversation. It's very long, it's very complex. So if you're trying to buy a microelectronic capacitor that's going to get buried under the ice in the Arctic, you might say to a supplier, hey, I need 10,000 of Chemet's CO603 size cap. Right? And they would send you part data, which is a document. Then you might respond with an RFQ. They might respond with a purchase order, and vice versa, ship notices, invoicing, forecasts, AVLs, all kinds of stuff. But really what happens is these are documents. They're digital documents that are getting exchanged back and forth between 2 parties in order to facilitate either a buy or a sale of a component. So you have those documents, and on top of that, you have the additional complexity of everybody in the supply chain being at a different place in terms of their overall digital sophistication or journey. So some of them may have EDI implemented, some of them might just be emailing spreadsheets around, some of them might have a full API suite. And DataHub's job is to sit in the middle between you and your trading partners, whether on the buy or the sell side, and be able to speak everybody's language and make the supply chain digital and solve all of those core problems, right? Transparency, resiliency, efficiency, all that kind of stuff for that entire communication. Next slide, please. Okay, so traction. We've been in business for about a decade. Over the last few years, our business has really exploded. We've had 50% compounded growth for the last couple of years. We are coming around the turn into 22 with about 30% growth already locked up. We're looking at well north of 50. Our repay is very, very quick. Our product is and company has been profitable for some time. It winds up taking about 3 months for a sale to pay for itself, and our customer acquisition costs are relatively low. Our margins, being a SaaS company, are quite high. Next slide, please. So our core competitive advantage is that we're born out of 2 industries. I'm a software guy by trade. I spent a lot of time at places like IBM, Standard Chartered Bank, Disney, Time Warner, AT&T, Pfizer, GlaxoSmithKline, and working on really, really big data problems and problems at scale. My co-founder, Chris Zizelka, came from the electronics manufacturing industry, and specifically on the buy side, and so brought with him a huge amount of information about that problem, that exchange of documents, that exchange of data that causes so many problems in the supply chain. We are built on those 2 foundations. We have a real commitment to data security and privacy. We have trade secrets that are specific to the encryption and security of data in this industry. We go through an annual process and compliance audit, and of course, we don't mine, anonymize, or use the data in any way that's not explicitly allowed by the by our contracts. We have a well-established brand and reputation in the industry, which is a narrow one, admittedly, and we are looking now to break out into adjacent industries and the public sector as well. Next slide, please.
30
So this
second
is Chris and
warning.
I. Yep. Thanks. This is back when we had a little bit less gray hair than we do now, I guess. And with that, I'll open it up for questions. My contact information is in the last slide. Yep. If anybody wants to get a hold of me afterwards, you can ping me at any of these spots and I'll respond.
Do you have any large contract manufacturers that are a part of your client base? Are they?
Yeah, we sure do. We have, let's see, on the contract manufacturing side, we have Mavenir, we have Mac. Boy, I'm sorry, I'm blanking right now, but we have, I would say we are just starting to move into EMS and OEMs, but we do have some very large customers on that side. We are primarily focused, we got our start with component manufacturers and electronic manufacturing distributors. That's where the bulk of our revenue comes from, is those two hops in the supply chain primarily.
And do you essentially make a sort of a custom connector from the hub to each of these component suppliers so that they can use something they've already got? Or how do you, is there a simple onboarding that you've got done?
Yeah, that's a great question. Yes. I mean, we retain that IP for sure. So it depends on the rollout. You know, if you have somebody, if you're talking to somebody like a DigiKey, right, they have a very well fleshed out API suite. Whenever a customer comes to us, like a Mac or a Mavenir, and says, hey, I want to buy from DigiKey, we are able to quickly wire up their APIs because we already have adapters built for them. So it depends a little bit on the type of integration that we are doing, but APIs are by far the most scalable. Other direct ERP connections can be reused too. So I'd say it's probably 60-40 in, you know, reuse versus build and hold.
Go ahead, David.
Okay, thanks. Hey, Tony, appreciate the presentation. You mentioned kind of at the end there that you were looking to enter into the public sector. Could you talk a little bit more about where exactly in public sector and kind of the use case application, assuming microelectronics, et cetera?
Yeah, sure. So because we play in the electronic space, our customers are you know, touching and moving components that are going to wind up in missiles and satellites and these kinds of things anyway. So we go through this audit process and we're aware that this part of the industry exists. We haven't addressed it yet. And that is sort of really what has pulled us into the public sector. So we're not specifically, we're just sort of dipping a toe in the water. The reality is, though, that this supply chain efficiency problem is one that is very acutely felt no matter where you are in the supply chain. And what we have seen is, as we've started to pay attention to some of the public sector asks, some of the RFPs and RPAs, they look very well suited for us, right? They are talking about things like supply chain efficiency, or I am paying people 10 hours to look through catalogs to buy parts when a machine can look through 1,000 suppliers in a half of a second. So they're asking questions and they're coming up with problems and RFPs that are really, really well suited to our technology. So it seemed like a good time to start to come into that sector.
Yeah, I would highly agree. And I think that the defense, you know, primes, so whether they be the Lockheed, the Boeing, the L3 Harris's, I mean, they manage multiple layers of suppliers, not all domestic. And sometimes it's difficult to know exactly what components are getting into which systems, but they're ultimately responsible for the system integration. So maybe we can connect afterwards and talk a little bit more.
Sure. Yeah, I'd be happy to.
Okay, any last questions for Tony? Awesome. Thank you so
Very
much,
good.
Tony.
Thanks, everybody.
Thanks.
That's Tony pitching from Orweaver Sourcing. Last pitch of the night, Zenesis. I'm sure I'm saying it wrong. Mark LaPena, founder and CEO, is going to be presenting. Hi, Mark.
Hey, thanks. Really appreciate it. It's Zenesis or Zenesis. We don't care what you call, as long as you call us. My name is Mark LaPena. I'm one of the founders of Zenesis. And first, I'd like to thank the guys at Deep-Tech Showcase for this very well orchestrated event. We're really grateful for the opportunity to be here. But speaking of team, at Genesis, we've got an awesome team. We've been working together for about 2 years now, preparing to change the lives of 1 billion underserved and unconnected people around the world. And through this vision, we aim to change, one life at a time, in the hopes that through changing that one life, many lives will be transformed. Now, that sounds great, but why else is my team awesome? Because we've got traction in the form of our first client, Airbus. On board the International Space Station, Genesis will provide solutions to Airbus's clients, and we'll share that revenue like we do with many of our partners. And we haven't stopped there. Genesis currently has 2 open SBIRs, one with AFWorks and the other with Space Development Agency, and we're awaiting congressional budget approval. So we have available contracting vehicles for any government organization to adopt our services. But who is Genesis? Genesis is a telecommunications company which uses lasers in space, which provide our clients with the lowest latency, highest capacity, and most cost-effective solution to support metaverse or any other universe you operate in. And we're unregulated. But why does that matter to you? Slide. It matters because no matter what technology you use, where you're at or what you're doing, nearly everyone and everything needs to connect. Northern Sky Research tells us that between now and 2025, that global data consumption will more than triple to 35 gigabytes per month per user. Now, add to that metaverse, and Genesis is perfectly positioned to capitalize on this massive inflection point of both technological growth and digital awakening. Now, this is huge because, slide, much like LA didn't solve traffic issues by adding more lanes, well, global connectivity is not going to be solved by adding more fiber. So what do? Slide. Our solution to this massive problem is lasers in space, and we call this ZenLink. ZenLink uses lasers to interconnect 72 satellites and 120 data centers. And we do this because lasers in space move data 47% faster than fiber on the ground, and that's just based on physics. But also based on physics, lasers can move far more data than any other method. And another benefit of lasers in space is that they can travel in a straight line between satellites without going through interchanges or teleports, over thousands of kilometers unencumbered. And we route them in real time dynamically based upon the most optimized route. Slide. We do this with Genesis IP in a minimum viable product approach to generate revenues for more, about 1/20th the cost of other satellite constellations. Now, by taking this approach, we've selected markets which are experiencing the most growth and are unsaturated and are seeking abundance where currently there's nothing but scarcity. Now, this in and of itself is the very definition of disruption. Slide. Now, the best part is we're sitting in the center of, I guess maybe the proverbial catbird seat of a total addressable market greater than $1 trillion. Now, of that, total, 45% is satellite communications. Now, we're also not sitting here telling you that we only need to get 1% of that TAM to be a unicorn. No, actually, slide. We've identified and penetrated the markets of network as a service and mobile backhaul and Earth observation for a combined targeted total addressable market of a little over $100 billion. And this TAM expects a combined and compounded annual growth rate of greater than 25% year over year till 2030. Slide. But don't take our word for it. We've been tracking our own progress, and that's what smart companies do. Since May of this year, we've been converting 12% of our prospects into qualified prospects and 30% of them into in-depth product evaluations. And 70% of those are converting to become committed partners and customers. Slide. Now, while that's all impressive, what's equally impressive is the fact that, we think about the kids sitting in a garage somewhere that are devising our demise. So we purchased ownership in our supply chain and became vertically integrated and virtually integrated where we couldn't do that. And now we have a defensible moat, owned intellectual property and long-term revenue share partners. And our supply chain is now vested in our success contractually, morally, and of course, permanently. Slide. Of course, to, make sure we stay on track, we've assembled best-in-class advisors from L3 Harris, OneWeb, Orange Business Services, Georgia Tech, and Goldman Sachs. Today, we stand here with $7 million in committed capital on a $20 million round at a $55 million pre-money valuation. $3.5 million of that is on a team effort term sheet. And with that, I'll thank you for your time and take your questions.
Awesome. Open up the floor.
So are you doing satellite to satellite and also satellite to ground, or are you doing just one or the other or both, and also any terrestrial stuff?
Yeah, that's a great question. So we actually are building a satellite constellation in partnership with Airbus. We're actually using the same satellite architecture that OneWeb uses, only we're using a larger bus because we're flying a little bit more complex equipment. So we'll actually interlink satellites. Each satellite will carry 6 laser terminals, 4 for in-plane and cross-plane links, and then we'll have 2 for up and down links. So each satellite will push out anywhere from 60 to 120 gigs, depending upon demand.
You're not making the links. You're not doing the physical hardware. You're doing the system to manage it, or
well, so we're building. So our IP resides in a couple areas. The first area it resides in is actually in the hardware design. So the laser terminal that makes the satellite as efficient as it is our IP, and then the actual dynamic routing technology is also our IP. I don't know if that answers your question, but that's, yeah.
Close enough.
Okay, thanks.
Can you talk a little bit more about your work with SDA?
Absolutely. Yeah, so we're usually, well, for the first letter we got from SDA actually was an email from the director of LaserCom. And we had actually received an AFWorks SBIR, but it was unfunded. So we reached out to Heather Pringle, General Pringle at AFRL, and she introduced us to the folks over at SDA. So we got an email from them saying that they would actually fund our AFWorks SBIR because there's only 50,000, and they would of course get the benefit and save themselves 200,000. And AFWorks said no to that. So we had to reapply for a brand new phase 1 SBIR through SDA after we'd gone through a little bit of a lengthy kind of qualification process. Because quite frankly, David, I mean, being a startup without any performance history on program is really, really hard to crack that egg. We've been very methodical about the approach, very honest and just transparent that, again, we're the startup. But David, our approach here is if we get an SBIR, that's fantastic. We have 2 contract vehicles already in place. But our goal here is to develop a commercial service. And if you kind of see where SDA is going, and you kind of read the tea leaves, some of the consultants we work with have told us that more than likely what will end up happening is the satellite constellation they're building will max capacity, and then they'll end up having to buy from commercial anyway. So we'll be there waiting for them at the end of the day. So not a long time to answer your question. The short answer, not a long time. We're just kind of cutting our teeth.
Okay. Yeah, I mean, I guess, everyone keeps talking about the opportunity that the commercial market in space is providing, and there's a lot of excitement, clearly a ton of investment, but it still seems like the public sector, whether it be NASA or DoD, still seems to be where a lot of the revenue is. So I guess to develop whatever it is you're going to build that can then be commercially viable, we'll start there.
No, I totally agree. No, well, I totally agree with that. Here's the thing. Excuse me. First of all, when we started the company, our first technology was NASA licensed technology. And, here's the commercial guy, right, trying to solve a very, very hard physics problem. And we realized very quickly that the technology we licensed from NASA really wasn't as phenomenal as we thought it was. But, that's part of learning curve when you start a company. But, we're a commercial team that happens to have some really cool technology. We're not a technology company that's trying to, find a market. So if you look at our team, it's heavily weighted towards the commercial side. We partnered with Best of Breed, with Space Micro, Atlas Space Operations, Assured Space Access Technologies, and through creative, relationship building and revenue share opportunities, we actually bought ownership in those companies without spending one penny of cash. So we look at this through the lens of, not build it and they will come, right? Because I'm a fundamental space guy. So I look at a business and I say, because I've invested too. So I look at the business and I say, okay, where's the technology risk? Where's the financial risk? Where is the market, market adoption, right? How do you actually make money? And what's happened in the space industry with the SPACs and all the craziness is that nobody's really met the fundamentals part of it yet. The technology is really cool, but eventually one day you got to pay for it, right? And so we looked at it from a bottom-up approach, and we said, let's generate revenue. Let's do one equity round, right? And then let's raise the rest in debt. That's why we added Jim Lane from Goldman Sachs on our advisory board. And we looked at it through that model and said, when we commercialize, then we have the right to go out and say, hey, OMB, we're actually doing it right. We actually do genuinely have, dual use. We can segregate your entire architecture. Do you want to buy a service, or do you want to continue to try to get 17 different satellite companies to build the same product?
Okay, sorry. So I see that you've raised a $20 million seed round. Are you trying to raise currently?
Correct. Yeah. So we've got 7 million of that committed right now. 3.5 million on so 3.5 million on a team effort term sheet, 3.5 million soft circle from EQTAL, Steve Taub, one of the ventures, and a private family office here in Miami that we were introduced to. And we've got 3 lead investors right now that are, I can't mention names, but very, very large, well-known marquee lead investors. Ever since we started talking about metaverse and the latency issues that we solve, it's like, somebody lit the Christmas tree up.
When are you trying to close the round?
I feel pretty confident we'll have our minimum bogey of 10 million before the end of February. I found that, like I said, the pace of the leads tends to move more quickly when they know they're not the only one trying to invest.
That's very true. Thank you.
Thank you.
Awesome. Is that the last question? Any last questions? Awesome.
Thanks again.
Thank you very much, Mark. A quick recap of who we heard from just in this session. We heard from Xenesis or Xenesis, however you would like to pronounce it, Orbeaver Sourcing, Connexio Cloud, and Symbet Corporation. We had an excellent group of panelists for all the sessions, but this one in particular. David, thank you for joining from Shield Capital. Frank Levinson, who was with us for a number of sessions. Tina, who might have dropped off a little earlier, but she was here for the other 2 sessions. Hanko, it wasn't Guy, it was, we had a D from Cyber Capital, and Rhys Schroeder. In the second session, working our way back, in the computing session, we heard from Arcs Nimbus, Edge Impulse, Tarden Silicon Systems, and Coherent. And we are joined by, in addition to those that I mentioned before, Deidre Williams, John Lee, Kenny Vasig, Darren York, Ryan Hatcher, and the first session, which was an open topic, not connected to the ICT theme, Fuel Gems, Unspun, Predo Battery, Bluespace, and Project Vista. And on that panel were Mark Brodner, Adar Sokar, and Rhys Schroeder. Thank you, everybody, for joining. Another excellent group of companies and panelists. It should be a blessed end to the year and a great start to the new year. And wishing you all the best wherever you are. And hopefully you have some vacation time coming up and some time to recharge before jumping into Q1 2022. Thank you, everybody. Have a great rest of your day.
Thank you.
Thank you.
Good Christmas. Thank you. Bye.
Holidays. Happy holidays, everyone. Hanko, are you back from South Korea?
Yeah, I am. I'm back actually. I'm back a few days ago.
That's awesome. Welcome back.
Yeah. Thank you. Yeah. I enjoyed the trip. As much as I, but there's no place like home, right?
Oh yeah, of course.
So
sleeping in your own bed, it's very. I don't know. It's very nice. By the way, just let us know if there's any companies you want us to connect you with, because I know there are quite a few that you had questions for. So feel free to reach out to us.
Right. Yeah, I'll do it. Thank you. And are you guys coming to CES in January or not?
It happens. We're there.
We're debating. We're
You're debating.
No.
Oh, okay.
We're debating.
I am. Oh, okay. I'm scheduled to go. Go unless they shut it down. So I know I'll be there unless they shut it down. So hope not. But
unofficially, Leora was supposed to be traveling for CS, and we're probably going to cancel it just because it seems like if they're unsure whether or not going to happen or not, then we're going to be unsure about us joining. And then Max Frischman, who's our chief business officer for our sister company, is also planning on being there.
Because I was with you because when I was leaving out of South Korea, Seoul, let's change the restriction, right? So I received something called the quarantine waiver to enter the country because I was invited by South Korean government, right? But they said they're not going to do that anymore. So I got kind of locked out on that one. But what happened was when I tried to enter to US, our administration changed from PCR test from 72 hours to 24 hours, right? So that means that you have to find a test result, testing site give you results within 24 hours. Otherwise, you cannot get on the plane. So I was scrambling, and it was an interesting experience. But I got home. So yeah, hope.
There's a great new industry called pandemic testing. They make a lot of money.
That's right. Yeah, you are correct. So. Alrighty, well, good to see you guys. Always a pleasure, and thanks so much again for the great program like this. I really appreciate it. Like I said, I mentioned this program a few times, during my talk because as an example, how the globally we work together. So yeah, alrighty.
Awesome. Thank you so much. Appreciate it.
Thank you guys. Appreciate it. All right, take care. Yeah. We'll see if you come to Las Vegas. Okay. So thanks.
All right. Awesome.
Take care.